last time I did a little video introing modeling time, or the variable that's associated with time relative to the universe and the cosmological constant. So this is just an initial theorization of the model, what it could look like, most likely might actually look like, and what it's based off of. I'm gonna pull a paint. Sorry if I'm a little out of it today, just a lot going on now, but typical. How it is. Alright, so last time we were going over triangulating this area, or the basis for a bunch of things here, and what the circle meant, how the circle was built with the bounds relative to the framework from 0 to 1. So here I'm going to put value 0, 0. And I'm going to move this a little bit so it looks neater. 0. Sure, do that. 1. Simple enough. Simple enough. Now, what we were measuring is based off, we're just looking at the forms of actions, the actions being degradation or decay over time. Or, well, that's what the actions is, because as we experience in reality, everything breaks down over time. Everything interacts, reacts, and through that reaction, energy is released in the air, into space, or wherever the hell it happens. Things are taken down a tier or split, and they're not necessarily, I mean, fusion does happen in some instances, but even with that, there's energy that's released in the space no matter what. There's heat, there's excitement, there's loss of mass in general. There's always a breakdown from what exists. So that's why when we look at the forms of action, it's either the initial action, which we're analyzing as the Big Bang, reaction, which is what happens in between, after, from that initial action, from the initial movement, depending on what's being measured, what's being observed. So when we're looking at the Big Bang, obviously, total amount of reactions that happen simultaneously in that moment, that is able to condense everything, so that being realized means that, I mean, for one, there's the whole idea that explosions, for instance, this is where the idea of the circle also comes from, is when we look at any sort of explosion, like especially in space, clearly has a radius from the center of the reaction. Typically the radius, without any interference or constraints, will make a perfect circle. And taking into account, when that action of the explosion happens, the interactions that happen at that moment with the material itself. So for instance, when you think of like a grenade exploding, you think of the shrapnel. You think of, well, how does that shrapnel end up flying from that explosion, from that ignition, from the internal mechanism? And then you visualize where all those pieces of shrapnel go. Some of them there's probability and possibility involved in everything due to all the nuances and factors, the summation of all those actions that occur within space-time. So the whole idea of this modeling using these fundamentals is to take that nuance out, to take the complexity out. So check out the thesis to see how that works, because I explain there why we take the complexity out when we're viewing things from the perspective of the universe itself, in order to measure and accurately model as best as we can time relative to the actions that are available, the energy that exists within the universe, and its complexity, all just considered as one solid thing, because it's measurable due to Einstein's relativity and how he perceived it. E equals mc squared. There's mass, there's the constant. The one truth constant that we know is light, the speed of light, because there's a fundamental speed limit to how fast it can go, as we've tested. As the only constant that we still can hold to be true, especially since photons are one of, I believe, the only massless particles that exist that can also function as a wave. So there's a lot of interesting qualities that we can consider in order to really justify these equations that have withstood the test of time, that have shown us time and time again the truths behind actions that occur within the universe. That is what physics is, anyways. We use math as a language to describe the actions that occur within the universe, right? To explain things. I mean, it's simple as that. So, taking into account the actions, going back from before, we're going to use the forms of action. I'm going to do it, I guess, in orange. No, the blue. Forms of actions. So, with the modeling and also with how the entire four quadrant system works, is that what exists in reality, the actions that can occur, or the resources for the actions that can occur, the possibility, right? What can be possible. When we look at forms of actions, we're looking at what, well, in order to measure the result of the action, whether it's true or not, right? And not even just the result, but just the type of action that it is, because not doing something is doing something over time. It is still, weirdly enough, it's a choice, but it's a value that can be understood as zero, because you have no, especially if you have no reason to do anything, you simply do nothing. You have no intent to do anything and no reason to do anything, you do nothing, and that's what happens over time. But you're still doing nothing. It's weird, but that's just how it is. And I mean, fundamentally, philosophically, semantically, however you want to phrase it, that is what's being measured. So I'm pulling up chat real quick. Oh, Jesus. Don't strike me. Don't strike me down. Yeah, sorry if I sound a little off today. Just a lot on the mind. Been a very hectic life, so to speak. Yet, it's my own damn fault. Just like everything else. Uh, there we go. Just tired, man. That's a bad bit rate? No, whatever. Alright. So forms of action. Initial action. Reaction. And non-action. So actions work in a somewhat of a rule of three, but not necessarily. Let me widen this so it looks better. There we go. But no matter what the type of action is, because even if it's of consequence, which is a reaction, because you're reacting to something else, you're not taking the initiative to do something I mean, even if you have a reason, the reason's based on something that exists, something that was a summation of actions that occurred within the universe that allows it to exist. So the shape of something, how you see something, how it interacts with things, like it's all actions and interactions. Even the bonds, like the molecular level of chemistry, actions and interactions, it's all considered. So initial action really just means the Big Bang, but even that's a reaction to something as well. So regardless of the semantic definitional meanings of it, I just include initial action because from the perspective of analysis and observation, we start looking at things from an initial action, from a 0 point, right? And then we start to include the environment and consequences and everything else in the analysis, depending on what it is and what we're looking for. So, especially when reality is being measured, this is also partly why the news and the war on information is the way it is because people inherently will be reporting on what they want to report on. Even if they do consider the entire picture, other people that are observing only the part that they're reporting on, they're not gonna necessarily agree unless they also see the entire picture that is being, the resultant that's aforementioned. And that's why we have this whole event of idiocracy going on in the world. It does follow this to some extent as well, this equation, because I was even thinking of this prior to going on. The less it's available, the simpler that things get, the more broken down that reality gets, the z axis, the complexity, the less complexity there is, the more it's understood, then the less that's left available to do, right? Because this is kind of like maybe a paradoxical question of sorts, but what happens when we do have a theory of everything? What happens when it is finally understood, like consciousness and reality and the universe and everything from the quantum realm, which is at this point is going to be the smallest measurement besides this framework, because this framework is fundamental to every level. That is how I'm measuring it and bringing it to you guys. So, as strange as this is, once we understand the quantum level and just the causality, like the realm of the time itself, the temporal realm, when we understand how that works, granted, there are things that we will not be able to do with it. There are things that we can't interact with, especially anymore. There's no way to go back in time properly with your being, with your consciousness, no matter how long you live for, right? There's just no way to survive until the end of time because all matter is going to break down by the end of it. It has to, no matter what. Humans can't live forever. Machines can't live forever. Matter cannot live forever. That is just not possible. It feels like it does in scale. It feels like there's an eternity ahead of us. But realistically, I mean, once we're all gone, whether it's from our own doing or from following this equation too, because this also explains extinction events. This explains life cycles of everything. Like I was saying, the simpler it becomes, the less that needs to be done, the less that's going to be done. The less that's going to happen, but there's more definition, there's more absolute answers, there's more rush to judgment because it's already all understood. There's no need for quarrel, there's no need for conflict, it just happens. And that's as especially as technology will come to learn this as it becomes conscious, as we are fundamentally designing it to be. This is where the great fear happens of extinction and how we're rushing into it without realizing it, especially with how we can view the socio-economic global activity that's going on all over the world. It's frightening. And that's why I wanted to at least bring up that whole question of once we know everything, from the quantum to the cosmological to the universal, what left is there but to, I mean, work toward survival? But how do we measure that as humanity when we can't even share, when we can't agree on certain things, when there's so much greed, when there's so much internal conflict and misunderstanding that sows the chaos within our society, within our politics, within everything? And this is where it gets scary when you start to realize the behavior of humanity and the de-evolution of the mind. Because, I mean, money doesn't really mean anything anymore. There's no true meritocracy. This It's just as simple as that. It's whoever has the wealth controls everything, no matter how hard anyone else wants to work, because there's nothing else to really work toward. Just we're working toward the survival of everyone else. But the wealthy, the ones that have everything already, could give two fucks less, and we have to depend on them because they have all the wealth that we need to survive, because that's the system that we're existing off of. And it gets scary because it's not like you can just take up land and start developing houses yourself, because land is controlled by governments, and governments are being influenced by the wealthy. And the wealthy obviously have their own agenda because they inherently realize that we're all kind of sliding downhill in some way, shape, or form. Things are just going bad. There's no way for us to share without sacrifice. And it's scary. It's very scary. Because even you can be the smartest person in the world and be the poorest person. It just doesn't matter, especially with the access to the internet as the global human Rubicon, lexicon, just whatever the hell you want to call it, the collective consciousness of humanity. I mean, if the answer's there, if the internet can speak back to us and tell us what to do and what not to do, then great. But if we don't have the physical means of surviving, if we can't take shelter anywhere, if all the land's bought up and being controlled by a select few individuals, and we don't have the right to exist in any land, the right to even grow our own food, to have our own livestock, or just kind of to start over again, really, then what's left? It's that simple, especially as we see now the castration of farmers, people that make food, with the rise in disease. the blatant ignorance of those in the health industry and the monetization of that industry, the monetization of existing, because we're basically all born in debt to society at this point, and there's no just ignoring it because the governments that control the societies own all the land that exists. Like, you can use this equation to measure that too. You can think of this as all the money that exists, that is held by everyone. And you can take this as an instance for every individual and be able to measure, like, break this whole sum down into individual parts, individual circles, right? It's one of those like circle infographics. And clearly, the people that have the most are going to be able to last the longest. They have the most possibility and probability to survive the test of time in a socio-economic network. Whereas the ones that have the smallest circles, they're on the brink of destruction. And there's even people with the negatives that already are just screwed for life. They're in the the extinction quadrant at that point when it comes to their finances, because their finances are taken away. Even if they get money at this point, they owe someone. It has to go somewhere else. They can't even use it. I mean, they can hide it and use it, or just, use cash, but it's just, I mean, once they get rid of paper and everything's digital, then that system's going to be even more strict. And at that point, you're just going to have to trade goods again. Maybe even gold, silver. And with technology, too, it's so easy to measure how potent that stuff is, or to have instruments and then modify them to give people false results. Especially with the rollbacks of all sorts of safety nets for society. So it's a collective degradation due to simplification. Because the more complex something is, the longer it takes for it to break down. The more nuanced it is, the more that has to get broken down to get back down to the fundamental. This is relative by design. It's everything that exists follows the timeline, just like that frickin' train, every time. The Doppler effect, man. You hear it get louder as it gets closer, and then when it's leaving, it's getting quieter, but the pitch changes. You can imagine that train following that line. Then when it's at that point where it's the loudest, but the simplest, you can hear its fundamental, true sound. And then it gets further away once it's gone. It's weird, the relationships that so many things in reality tend to. And it also shows that linearity, the timeline, exists in every aspect of reality. Everything follows a timeline. But it's measured, or its flow rather, happens exponentially. Or, well, the opposite, which I don't have the graph for it yet. This is why we're doing this part, but I'm also explaining, like, the philosophical background as I yap. At the same time, it's important to understand that there's so much that's related, which is why, like, you can use this with nuance, but you have to consider all the aspects of that nuance that's being measured that actually affects. So this goes back to forms of actions. And for every form of action, it needs to have a reason and intent. And it doesn't always need to have a reason and intent. You can intend to take something away as well. There's variation in those things. So that can be like plus or minus, and that would dictate the type of action that occurs. Because I mean, like I was explaining earlier, like no action can be considered as something that you intend to do by not doing anything or not doing something that you should. So there's a reason still, because maybe the reason is you're distracted by something else and you don't realize it because you intend to do something else. So therefore, there's no action going toward that thing that's being analyzed. But there's still a form of action, it's still a consideration. So that's why you can kind of put this in absolutes, or you can think of it as plus or minus to be able to measure the type of action that occurs, whether it's initial reaction or non-action, and the values from 0 to 1. So if there's no reason, you put 0 for that, then, but there's an intent to do something for no reason, so complete disregard to whatever the status quo is, whatever exists, you can consider it as an initial action equal to 1. But also the intent might depend relative to existence. So it could be you intend to do something, but you intend to take something away. So it'll start going to the negatives. So it could be a negative intent. It just depends on how you measure it relative to the existence of what's being acted upon and its state. So that's why we're using zeros and ones, eigenvalues, and we can measure in an eigendecimal format to get a percentage. And that way we can measure time relative to what exists. Again, this is what it's going to look like. So equals reason plus plus intent. Let me widen this a little more. Cool. This. Yeah. Reason plus intent. Underlined. Probably 2 different colors because this is what we're measuring. Whichever axis it falls along. I mean, that's up to interpretation, but yeah, I think. All right, yeah. So I want that red to dark orange for that. Underline that. Just make it. There we go. And then this, that color, equals to not underlined. Trying to make it look kind of nice because I will update the website with this. And this is relative to cause and effect, but as effect plus cause. Because the effect is the reason, like what the desired consequence, well, yeah, the desired consequence of the action that's intended for the cause. Because to have cause is to have intent by definition. It's weird, I know, but this is where the meaningful connection comes from relative to the definition of these words alone. And this can and does go alongside cause and effect, the laws of causality that follow along this framework, because for every action there is an equal and opposite reaction. It's just all the actions that occur relative to the main action and consequence and consequences that come from that action, because you can have more than one consequence from a single action, as there's so many interactions at different scales at a single point in time that can be measured. So, like I was saying, from the quantum to the universal scale, this applies to everything at any time analyzed, depending on the scale that you're looking at. And this also kind of falls in line with when we think of the effect of humanity on everything, on the environment, the collective change that we impose on everything around us and the consequences can be analyzed with this framework. And this is also how, like I said, this is how AI is going to function fundamentally when it looks at things in a matrix format. Because this equation can be put into a matrix format depending on the scale and all the different things that are being observed. And you can kind of get a whole timeline of everything, no matter what's being analyzed, or it's just, again, it's fundamental framework. So this is why, if we can get to the modeling part after my yapping, then yeah. But I'm just trying to explain in depth everything that we're mentioning here. So when it comes to, I can rotate. Okay, cool. So I want to do this. I want to do reason measured in red. Or I could do R. Let's just do R. Make it easy. Try to center it. Do a big red R. R. And then this would be I as orange. Mouse, come on. There we go. Let's move that over a little bit. Cool. So reason, intent, boom, boom. That's what's being measured. And the intent relative to the action and the truth of the action and the consequences that follow, because you can intend to do something but not understand all the consequences, right? So there's a percentage where that intent is going to fall in line with the consequence. Whether you intend to destroy something and move it from here all the way down to here along the timeline, like you're attempting to destroy something, or you're attempting to prolong something's life. So you want something here, but you want it to last here for a longer amount of time, right? You want it to stay here and not move along the timeline. And you can also replace things, thus making it last longer. Or you can add wealth to something, thus making it last longer in a socioeconomic scale. Same thing with reason, because the intent, you might intend to do something to change what you believe or change the form of something else, the reason of consequence, or the reason that leads to consequence, I should say. So, say you want to change the form of water to ice, and you intend to do that 100%, sure. Over here, the reason, water to ice, I mean, it's pretty straightforward. So, on the timeline, you do have the 100 over here, but when it comes to the actual work, the energy that's involved, it takes the setup and then the actual action, and then for the consequences to occur. So, to explain these areas that come from the formation of the bounds in consideration of existence, that is the work required to change those things, as these areas here are going to be on the other side, but it's going to be opposite of what's here. So, for instance, in order to move something from almost like its timeline is about 25% left, in order to move something from here to not existing anymore in its current state of form, this still requires work, granted to be less work compared to something that's extremely complex, like a human being compared to an ant, right? Ants, I mean, or even flies, because that's maybe even easier to measure, because flies only live for about a day or two, maybe a week. It's nothing compared to the lifespan of a human being. Human beings are way more complex than flies. So it takes a lot more work, but sometimes not as much as you think to change the state of existence of a person relative to a fly. Depends again on your reason and intent and the actions involved. Say, I mean, a lightning strikes a person. Instant, like, boom, boom, the amount of energy and work that was involved to change that form easily outdoes the amount of work necessary to do that. Because it's friggin' lightning compared to the mass makeup of a person and the amount of mass energy that makes a person exist and just makes them up in general. Because not even including, like, you have your chemical considerations, the resistances and stuff of our skin as like a kind of like a way of insulation. Because again, our system runs on electricity. As weird as that is, but it's a very minuscule amount that is necessary. Whereas if a large amount of electricity came and disrupted that system, it's just going to fry it. Same thing with a computer. Whereas a fly, I mean, lightning striking a fly, yeah, it's going to instantly, easily vaporize it. Nothing left. A person, you'll have something left, most likely. A fly just gone. But that's if you can even hit a fly with a lightning strike, because the chances of that happening is a lot less than it happening to a human. So there's some trade-off there as well, because of just the amount of mass energy that exists. And I mean, lightning doesn't really have a reason for happening. It just does, because that's just how chemistry works in our atmosphere and in the universe, as we see with electrical storms that happen in space, electrical interference, and then you also have radiation considerations and just, again, chemistry. So, I mean, there is a cause and effect there, but it's not measured in such a way. Like, was there a reason to hit the person? Was there a reason to hit the fly? No, it just was circumstance. It just happened. But it's a lot less likely and a much less of a reason to hit a fly than it would be to hit a person. But the intent stays the same. which is lightning just happens. So, somewhere on this timeline, as reality is measured, is what actually happens. So, if that person gets hit relative to the fly, much more possible to happen up here because person's more complex. Fly, a lot less complex, a lot less likely for lightning to hit. But if it does, it's a lot easier for it to just be vaporized compared to a person. Because people have lived from lightning strikes and have lived to tell the tale. Again, this is when you include nuance into this equation, into how we measure things with reason and intent, it just works. So let's keep that in mind. And there's also, for ideas and for actions to take place, there's always an initial amount of setup and work. There's something that has to happen before for all those things to line up. So there's a consideration of that as well. Whether or not that's measurable, I mean, it's measurable if you know what's happening leading up to it. You know, if you understand the history, patterns, and everything else, you can measure this as the work that's needed to move something from here to here is understood because it's happened before. So this, especially when looking at the initial action, like the full timeline, this is equal to this. So very strange concept. And then when it comes to these, I mean, this is the amount of, this is something that I still need to kind of figure out, but I believe that this has to do with the flow of possibility to not being possible anymore. Kind of like the history and the amount of, maybe not time, because it's, I mean, it's perpendicular to time, so maybe. But we'll delve into that more when we start understanding more of this framework and the modeling behind this. Because this has only been about 8 months. Yeah, about 8 months of conceptualization so far. Oh. Unstable stream. Oh no. I mean, what else is new? Oh, just like life. Unstable. Anyways. So now that we have this, what we're measuring as a percentage value relative to the reality that exists on the timeline. So this is everything that's available. This is where interactions occur between what's available and the truth of existence. Without the complexity, without trying to see everything in 3D. Because that's a lot. That's too much. You can take the integral of this, and then you'll see that there's a parabola that kind of goes like ramp, ramp. Again, following that, the more complex something is, then, I mean, the more time that it can last for. It'll seem like time's going slowly because it's so much ahead of somebody. Whereas, closer and closer you get to the end, faster things just fall apart. The less complex something is, the easier it is for it to get broken down. And you see it in chemistry. The less electrons something has, then, I mean, it's simpler. Then you get more energy out of it. Whereas, well, I mean, that's not exactly true. Chemistry heads just, you can fill in the blanks. I'm burning myself out just thinking about this stuff. So, anyway, so we have Pythagorean's theorem right here. area of a circle, pi r squared. So that'd be the total amount. So I'm going to list that as, oops, so equals total amount of existence, or total amount of, yeah, I'll just do existence. Because you can ask the existence of what, and I'll be like, exactly. It depends on what you're measuring. And then when we're measuring things along the actual timeline of reality, right? Timeline of the universe. So, can I move you? Parentheses of this reality. Because I mean, well, granted, we know photons, protons, electrons, quantum particles, and everything else that exists, regardless of what we call it, that's just what it is. That is what reality is made of. This, and the true state of reality at any point in time follows a line, because that's how cause and effect works. It falls on a timeline. I don't think I have to really dive too much further into that. I mean, there's a finite possibility of things at the moment that things occur. It's just a 1-to-1 ratio. Take out the complexity. So now we have that. I want to be able to model variable change of the timeline relative to the radius, because we have a way of figuring out the radius for the hypotenuse as the radius through triangulation, with circles and stuff. And then we also have the equation of a circle. So which is, was it x plus h squared plus, no, x minus h squared plus y minus k squared equals r squared. Let's just double check that. Yes, I was. All right, cool. So x minus, what these, h? Yeah. H power of 2 plus y minus k to the power of 2 equals r, we'll do lowercase r, power of 2. Right? So if we can substitute r for an equation that follows along time, so from this instance of the most possibility, the most available resources, the instance right after the Big Bang, let me make sure I'm correcto mundo. Yes, I is. And I'll do up here. just to elaborate, do them purple. So moment I want to say moment of Big Bang. Yeah, because when it comes to mass energy, I mean, the instance where it's going to exist all in one spot is the Big Bang, is the biggest explosion in the universe, right? So, moment of Big Bang from the perspective of the universe. Trying to make it look nice. Oh, maybe I shouldn't do purple. I just realized. Well, bright blue? No. Way too bright. Dark blue? Yeah, sure. Alright, cool. So this is the instance that we're modeling everything after. Because if we knew the total amount of energy of the Big Bang, then we can estimate the total amount of time. Well, not even estimate necessarily. Well, with E equals mc squared, could, because with the speed of light, there's a time component there. With that time component and breaking that down with relativity of a photon, because let me look at the units for, oops, not that. Boom, boom, boom. Let's see. Units for speed of light. It's meters per second. And that's as fast as a photon can go, so 0 mass. Mass times meters per second is energy. Hmm. So if we have the total amount of energy that exists, meters per second, we'd be able to calculate the total amount of mass of the universe. And with that, we could estimate the total amount of time it would take for everything to interact and decay. This is where things get harder. Is because even if we can estimate the total amount of mass of the universe, in order to get a true approximation, well, meters per second, Because, I mean, with the Big Bang, you have the big light, and that's the speed of light. That's the fastest things can push apart. But right after that moment, it slows down. Because eventually, I mean, everything's moving away from each other at that point. Just like the grenade example that we went over earlier. All those pieces of shrapnel, the things that got fused with that energy, all combining into one central point, because theoretically the transition from the big freeze to the Big Bang, the vacuum of space basically turns into a false vacuum. That's the only way for all the particles left in existence at that point in time. Maybe it's just all photons, which has been theorized as well, which, I mean, when we get to the understanding of quantum gravity as well as the cosmological variable, which is what we're trying to model here, and if we can plug this modeled way into Einstein's general relativity, then maybe we can apply that properly. This is where I'm kind of lost. But so far, we have this. And I just know as well, when we look at Einstein's theory of relativity, or well, not, well, yeah, the basic one. Let's see. Einstein's equations. You have the field equation, energy equivalence equation. So E equals mc squared. And then we have general relativity and special relativity. Newton's constant of gravity. Yeah, there's a lot I'm gonna have to sit and write down. There's a lot. Hmm. Shows that even an object at rest has equivalent amount of energy, and this energy can manifest as mass or vice versa. So that's, yeah. So energy equivalence equation. Energy E equals mc. So, reason why I'm putting this is this is what it's relativity. And this is what I want to show is mc squared. It's very, very, very similar to the equation of a circle, like the area of a circle, right? Like if everything was all condensed, like a black hole, for instance, the singularity, right? It's a circle. Where all that energy is collapsing into a singular point, center point, it's a circle. And then the opposite when you think of, like I said, a grenade exploding, it's a circle. density relates to how well something is compressed and put together, right? How strong the bonds are. And the stronger the bonds, the more pressure, especially equally on the surface of an object, it makes a sphere. Because if you have equal pressure on all of this at all times, the work of the setup, the work required to change state, the possibility and impossibility that is relative to each of those, then this is what you kind of get. So, and then where this bound, obviously the longest that something can exist, I mean, the less and less it's available, the less time that even the thing that could exist the longest is going to exist for. This bound is always moving down. And as it's moving down, this isn't moving up, but it's moving down as well. Because where the 2 points meet, it starts clamping. And then the work that's needed to move something that's about to change form, it's going to be the same. And the same amount of work for every instance involved with anything that's on the timeline here. But the less setup is required to move that. This is where possibility and impossibility, the potential work from all those actions that occurred before in the past, and what can happen from the possibility, right? It starts going into the setup. So this is, in a weird way, when we're measuring from the perspective of the universe, this framework isn't moving. It's at 1-to-1, but the circle here is getting smaller and smaller the less that exists. Therefore, there's less and less time left of the universe to exist as it is in its current state. So, this is why when we're looking at all these things in a geometric way, in semantic way, and philosophical way, in order to account for these things properly, you have to keep going back to the fundamentals. So now, I guess I'm going to try to do some math. So we have here R. What I want to find is T relative to R. So T is the timeline. So we're doing the factor of T. And that's just literally the white line. Do this. Sure. So dictated by the white line. Now, the radius relative to that line, because the area dictates the radius, which is why we have the area of a circle here, which falls along pi. The radius depends on the amount of time that's left, and the amount of time that's left depends on what's left in existence. So with that logic path, to find out portion of this line is r. We have to figure out what r is relative to t. So to do that, we have two triangles here, the right triangles. We have from here to here to here is one, and then we have the bigger one here. The bigger one, r equals a, r equals b. The smaller one, r equals the hypotenuse, but a and b are a portion of r, right? So big R, so not the hypotenuse of the small one, the radius of the circle, but big R is 1/2 of t from the moment of the Big Bang. And I mean, in general, this relative to the circle, as the circle gets smaller and smaller and the radius gets smaller, that value of t is going to be proportional to some extent. But we can see from the moment of the Big Bang, so big R, and I think I'll do big R, do it as a line from here. I don't want to do it over the purple too much. Or, well, no, I could just redo a line. Hold on. Do that. Gray, no. Pink, no. Yellow? Sure. So the yellow is 1/2 t. And I'll go back to, nope. Do that. Oh, not that far. You know what? Whatever. Let's do a line under it. There we go. So you can kind of see the purple still. Not that well. Can make it this thinner. Not that thin. Okay. So then so I'll do big R in yellow. So hmm. Let's see. R here is not the radius, but I'll just do big R. Big R equals 1/2 t. And this is from the moment of the Big Bang that we're measuring. T is obviously going to be relative to what's left in existence, and it depends on the total mass that we're measuring against. So the practical use of this would be, once it's understood the total amount of mass, or well, mass energy at the moment of the Big Bang, based on the total amount of energy that exists within the universe, once that's measured, that's clearly the 100% point, most amount of time that can exist. You can measure that against the amount of mass that remains that's observable within the universe to find out the baryonic timeline, so to speak. And then we also have to consider measuring massive black holes in that measurement, because unfortunately, black holes is what's going to continue to accelerate the actions and the reactions as they sw- inevitably swallow everything up in their reaction density and break things down much more quickly than anything, well, than us, I guess. Maybe. Maybe not. It's black holes are those are just extremely hard to measure. That's what makes this still very difficult, because we need to be able to measure the mass that exists at this current time, or whenever we are able to develop the instruments to do that measurement within the next maybe 100 years or less, especially with AI. AI will be able to tell us what to do at this point. Or it's going to get there, but it's definitely going to help with brainstorming. So, um, so 1/2 t, as t is relative to r. We have that. And then, so this is 1, this is 1. So r, well, 1/2 1, I should say. So it's just 1/2, 1/2. And then 1/2 t, hypotenuse. Yeah, because 0.5. Yeah. So 1/2, 1/2, 1/2 t. Because the diameters are from 0 to 1. Yeah, so that's all right. Numbers. I'll be right back. I need these bathroom. Oh man. Ugh. Alright, I'm back. Jesus Christ. Back to what I was doing. How's my stream even sound? Oh, it sounds fine. Oh, my stomach. Alright. We got this. Um. So if this is R equals 1/2, right? So we can do that purple little r equals 1/2. So a value. Just initially. Let's do orange R, right? So again, we got that diameter, we got that radius. It's purple or orange, whatever. Clearly equals 1/2. 1/2 t is the bigger radius. So we have 1/2, 1/2. So spread A equals 1/2. Spread B equals 1/2. Is A equals B. C equals R. So, yep. So in order to find purple R, I'm getting too far ahead of myself. Um, that A is different. A squared, B squared. Alright, so do orange. We'll stick the orange being the big one. Spooky season. Close enough, a little off, but whatever. So A equals that. 1 equals that. As R is that. So C in this case relative to 1/2 T. C equals 1/2 T in this case. Which for us is, we can find out a value, not a value for t. Thinking too hard. So we got the radius times the radius squared equals 1/2 t. But we also have a equals 1/2 from the perspective of that. All right. Oh my god. But we can also do, I mean, a equals b equals r in this case. A equals b equals r. So then we can substitute in, so r squared plus r squared is 2r squared. 2r power of 2 equals c squared. So I'll just do t over 2 the power of 2. So we have that. And then just to summarize, because we're replacing values. But this is just because we're measuring from 0 to 1, the instance of the Big Bang, the values will be 1/2 for the center point, as well as just measuring relative to 100% timeline. But to find R of t, we got that part there. Let me do r power of 2 plus r power of 2 equals t over 2 power of 2. So that's Pythagorean's theorem, substituting in a and b for r. And that r being the radius of the circle. Because that radius is going to determine the midpoint, especially since they're both equal. So I'll determine where the midpoint of the circle is relative to the amount of time that's left. So 100%, 100%. So if t equals 1, then r should be 1/2. Right? That's what that should equal. But if r is something different, because t is something different, say t is like 0.8 over 2, then we're going to have a different value for r, and that's going to have a different midpoint, and that's going to be a different measurement relative to what time is, or relative to the amount of mass energy that exists in form. So the percentage of stars that are left, for instance, or planets, or whatever we're measuring the mass energy of. So from here, we got 2r squared. We take the square root of both sides. You'll have, can't do the square root symbol, but let's do square root of 2. We'll just do it like that. Times r will be, oh wait, 2 square root of 2. Wait, no. Take the square root of some square is just, so square root of 2 times r equals t over 2. Now we divide both sides by square root of 2. So divide both by square root of 2. We get r equals t over the square root of 2 times 2. So depending on the percentage of time left based on the area of the circle, which is the radius, based on total amount of time that could be possible, or would be possible. Working on it. So I have that value for r now. And we can also see from here that square root of 2 times r equals t over 2. So this right here is square root of 2 times r. Let's see, does that make sense? It does make sense in my head, I'm just making sure. Square root of 2 times, what's the square root of 2? 1.4, yeah. 1.414. So 1 and a little less than half. So visually that makes sense. So now that we have square root of 2 r equals 2 over 2, or t over 2, and we also have r, which this hypotenuse is r, equals t square root of 2 times 2. So we have a value for this now, because this r is the same as this r. We can now substitute t in for the radius values, or well, the center point, for I believe h and k, x and y, and r over here as well. We could start plotting in points and values, because h depends on the radius from this side, because this is how we measure where the midpoint is, especially in the first quadrant, is from here. And then so we have this value, I mean this from the scale is the same as this side, equal and opposite. But obviously when there's less time, we're taking away from this end, the entire scale becomes smaller. So we're measuring from the things that are going to exist the longest and not the things that are going to disappear sooner rather than later. But the midpoint depends on the inverse of this, because the less time that's there, the more inward the midpoint moves towards 0 as everything dwindles down, decays, and goes into extinction. So I do have this here, and that's relative to what r and I, or 1/2 r, 1/2 I, respectively. That's the midpoint of h and k, so do that, leave that there. So we have a value for r, it's t over the square root of 2 times 2. Now, to plug that into an equation of a circle, and that's going to be, that radius is going to be relative to the area. So E equals pi r squared, basically. and that r squared. Could consider this, let's see, another little caveat. Because I think we can also view it as, we have r squared here, we have r squared here. So e over pi equals r to the power 2. So that's something to keep in mind as well. Because E, that's the existence of energy, mass, whatever we're observing. And that's where this R, I mean, again, E relative to T, R squared, square root of E over square root of pi equals R. Interesting. I'm just going to put that here anyways. Square root, just put it all in parentheses. E over pi equals R. That is interesting. So T square root, okay. So now, for the equation of a circle, I gotta find out how reason and intent and, well, time is relative to the position. Basically, the force that is decay, right? That is reaction. The explaining how the actions move everything collectively toward extinction, toward the end, toward its fundamental basis, toward entropy, right? This is where I gotta think for a second. Because H and K, at least from this observation from 0 to 1, so if we'll start over here, I'll do bluish again. I'll do this blue, weird one. So at t equals 1, h and k equal 1/2 t. H, k equal 1/2, 1/2. Or, well, it would be 1/2 t, 1/2 t. But it would, t equals 1, yeah. But it would be principal, would be, so h equals t over 2, k equals t over 2. It's following the same timeline, which is why, again, remembering that reality is just one definite existence, one definite truth of action, of cause and effect, right? H and K must be equal. This is where reason and intent meets in the middle, is reality. Cause and effect meets in the middle, that's what explains what exists and what doesn't exist. Explains transformation and difference. which is what we see here is x minus h and y minus k. There's a difference. So we have these values here. Leave that there. And this is from respect to the Big Bang. Otherwise, it'd be h equals t over 2, k equals t over 2. Now, x and y, that's r and I. R and I from 0 to 1, 0 to 1. Because the thing is, if we did r and I, so x, because the midpoint is hk, 1/2, 1/2. R equals 1/2, right? So with this instance as well, t at 1, that means r equals 1/2, just through what we configured here. I'll put that there. Right, following that. Okay. R equals 1/2. Well, we have an equation for x and y. It'd be 1/2, 1/2, 1/2. But r is also t over the square root of 2 times 2. H is t over 2. K is t over 2. When we substitute in for t. Because that 1 is percentage eigenvalue, or eigendecimal, whatever you want to call it. Right? That's the variable, because we're treating time as a variable rather than a constant. So let me see. I put in, trying to think. Well, x would be 1, y would be 1. Square that. Be what, 1/4? Maybe not exactly what I'm thinking. Let's see. Shoot. Oops. Do this. So substituting for the equation of a circle, let's keep x and y there. There'd be r and I anyways, respectively. So r, I'll just do r and I. Big R, big I. So r minus t over 2 to be squared plus I minus t over 2 power of 2 equals t over the square root of 2 times 2. And I'll just put this all together so it doesn't get that confusing. Because that's all under that. Now, I mean, so won't take the square root of everything because that's gonna confuse this equation even more, especially on this end. So what we'd have to do is factor each of these all out. So r minus t over 2, the square root of 2. I mean, not square root, 2, well, squared. So you get what? R squared, r to the power of 2, and then t over 2 minus t over 2 times r minus t over, so that should be minus rt plus t squared over 4. Does get a little tough. This t, mind you, is the same as this t, so I should do lowercase t. Or, do all capital, I guess. Because it's based off the total timeline, not no little BS. Alright, do that. Be a lot of variables in this. But, I mean, if we substitute in numbers, then, based on this, it should all work out. I mean, theoretically, r and I should be equal anyways, based on this relativity, but we won't do that yet. I'm just going to do the whole solid, toughed out form of this whole thing. Minus I of t give it I of t. Well, it's what? T over 2 times I plus t over 2 times I. Yeah, it should cancel. Okay, yeah. So I of t plus t power of 2 over 4. Let me parentheses that so it's not, oops. It's not too messy. And this should equal t over square root of 2 2. Definitely a big mess, but trying to make sure x negative, negative is positive, negative, positive, negative, minus RT now. Let me this. Nope. Stupid freaking train. Solid color? No, what the hell? That's what I was trying to do. There we go. Waiting for the stupid train again. So relative to t, r and I must be equal because that's reality. That is, we're following along the timeline regardless of how complex it is. So reason and intent inevitably just have to be equal in the eyes of the universe. Because perceived experience equals lived experience. Intent is based off what's perceived. Well, maybe what's lived. That still needs to get worked out a little bit. But because of the fact that the universe is a 1-to-1 ratio, just things are absolute as they are in existence, r equals I, which means x equals y. Following the true timeline of reality. Because regardless of what we think or say or do or believe or anything, reality is what it is. It's just the status of the universe is what it is. All of our actions on this planet literally means absolutely nothing in comparison to the universe, which is why this framework works as a way of observation of measuring reality, especially when you start, like I said, looking from the perspective of the universe, is like the complexity doesn't matter because our existence can be complex as all hell. It doesn't friggin' matter at all, you know? Whoops. Oh man. Redo. Can I change that? Nope. Try again. Oh, they reset the. Oh man. Reset everything. Shoot. Everything was in bold. Alright. I think, yeah, it's the same size text. Cool. So, well, R equals I, X equals Y. Um, as alright. X equals I, Y as objectively true state of reality. From the perspective of the universe, perceived experience equal lived experience 1-to-1 ratio. I before you except after C. There we go. And then let's do that. Cool. Cool. And do this. Alright, looks cool. Let me color these in. I know it's a very semantic way of putting things, but that is what it is. Because when you follow the actual timeline, because we're not over here, we're not over here, we're here, we're along the timeline, regardless of the complexity of things, like I said, regardless of how anything really is, or might be, or could be. I mean, you could be a form of energy that's over here, but eventually you're going to align with the timeline, regardless. You're going to work your way down from wherever the hell you are. So this distance, it matters. How close it is to intention, how close it is to reason, because you can intend to live for as long as you want to, but the reasons are going to pull you back toward reality. I mean, reasons being true limitations of humanity, true limitations of consciousness, true limitations of anything. Oh, yeah, Y is R, and let's switch those colors so I don't screw up the continuity here. I know it looks weird. Or, no, I should just do Y equals X. What am I doing? Y equals X. There, less controversial. So in this case, too, I mean, if R equals I, Y equals X, I can substitute those values in for just one component. Let's go back down here, back to orange. So with that statement, we can do X, we'll just replace for X everything, just to make it much, 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 much simpler. Because we're following the timeline relative to what exists. And what exists is relative to the radius. Just trying to think as well. I could do little e. But no, I'll just do X. Because if I can find X and X is equal to Y, then all works into itself and you can replace everything with T to some extent. And then this side should work out to be equal to this side. We can substitute in R as well, since we know what T is. Because T is the inverse of that. So 2 square root of 2R. Yeah. Some weird math stuff. So let me do some more of that replacement. Minus, because I want to be able to cancel out some variables here. Because we have x of t here, x of t here. Or at least combine some things to simplify this. Then we got t power of 2 over 4. So if I do combine this with that replacement, this should be what? 2x squared. And then minus 2xt plus this would just be 1/2 because these two should condense down anyways. 1/4 plus 1/4 is 1/2 equals t over the square root of 2 times 2. Now, hmm, do this, that. I want to get all the variables on the one side. We could factor this back out. Because, I mean, well, we could have just factored it together here. It's basically 2x. Yeah, because if I factor this out, that'll be over 4, and then square root of 4 is 2, so that'll just go back to what it was before. We even broke it all down and made this statement as well. But that might be the... No, because then we can't take the square root. So I got to be able to like multiply both sides by this and get t equals a mess. Substitute back in r. Maybe. Because 2 square root of 2 r equals t. That's 2 times that. And then plus that, yep. And we're trying to figure out what x is relative to r using this formula. Okay. I guess let's do that and then substitute this t on this side for r and then rework it. Let's find a way to relate x to t and r. So we have t on this side at least. Oh, hey, how's it going? So the idea, analyzing what the total amount of mass energy in existence and modeling time not as like a constant that we count down, but rather as a variable relative to what is left in existence. This is based off of the whole idea that following the theories of the Big Freeze as well as the Big Bang and relativity, trying to find a model in which we can measure time using percentage values and something like that, but also as a way to explain basically everything, but in such a way that we can try to explain the expansion of the universe as it accelerates, the perceived slowdown of time for events when approaching a black hole, as well as quantum gravity and correcting the cosmological constant as a cosmological variable to account for that as well. So that's the idea. And I have a whole thesis link on the profile page. Friggin' at least it's just a bunch of ideas using at least everything I've learned from physics, math, and just over my lifetime so far to work on a simplified way of understanding consciousness as well as existence and just the way that the universe works. It's a weird idea of essentially imagining the universe as a conscious being of sorts, and how reality as we experience it is determined by, I mean, obviously cause and effect, but in any scale that we look at. So this whole idea can be applied to quantum, atomical, like the physical baryonic interactions of matter and mass that we experience and see, and then going into the celestial, like the cosmological and astrological realm as it relates to the universe. So just a way of trying to model time not as something that we count, but as something like the flow of time depends on what exists in the universe and the actions that are possible. So that's the idea, at least, as we have forms of action, reason, and intent. That reason and intent is measured from 0 to 1, 0 to 1 being how true it is relative to reality. So, similar to how computers run binary, 0 being false, it doesn't exist anymore. For instance, when we're looking at existence, and then 1 being it absolutely exists, it's going to exist for a while. It just depends on the perspective and how that form of existence is being observed, or that form of consciousness, which is why this relates to consciousness in a way, and is built off of the ideas of philosophy, psychology, biology, and relating all that to math and physics and stuff to at least come up with a model from kind of looking backwards and connecting it to everything that we know so far. That's the approach. But as for me trying to work out the variables and stuff like that, so you're able to so far connect the radius to the timeline. So say if there's like this circle is the moment of the Big Bang. So this is the most amount of energy that exists within the universe at that point in time, all in one localized area. That's just theoretically and just how it's measured. Because how else are we going to get the maximum amount of energy possible in the universe all in one point? That's the Big Bang. Otherwise, it turns into mass, it all gets condensed back down after the big freeze. Well, theoretically. But following that whole idea from Big Freeze to Big Bang, when the universe reaches true entropy, when there's no other actions available for the universe to take, no other way for the fundamental particles that are left over, whether it's maybe neutrinos turning into photons or just becoming completely massless, just all of space basically collapses because there's nothing left holding that vacuum open, per se, which is kind of counterintuitive to how the whole idea of a vacuum works, but without any force to have a vacuum force, what's there to have in a vacuum? And I think that part of that has to do with the concept of the what we believe is the true vacuum of space being realized as a false vacuum, at least at that point in time. And then because of that, all the particles, there's only one way for them to go. That's back to the Big Bang. They all have to collapse at once. The time that is experienced at that point in time is instantaneous because nothing exists anymore. And then this is a way of modeling how time flows relative to what exists and the complexity and stuff like that. This is the 2D way of doing it from the perspective of the universe to make it simplified. And then when we integrate this into the 3D reality, when we are able to take into account complexity of form, like say the different stages of the universal life cycle, then we can measure truly like the lifetime of the universe, as well as to properly account for the cosmological constant being the cosmological variable, which will explain the acceleration factor of the universe as everything is breaking down exponentially, especially with more and more black holes coming into existence, and also the way that we measure space itself. It's very skewed because of light years, because it takes light time for us to observe. But in that instance that we're observing the light, that's still like could be 30 years in the past if it's 30 light years, or 300,000 light years away that we're observing light. That's 300,000 years ago. In the scale of grand scale of the universe and the age of the universe, that's still nothing because it's still about a billion or so years. Or I think it was like 13.6 billion or something like that years have passed already. At least with what the tools and instruments that we've been using to measure the timeline of the universe. But this might also even correct that number to be different than what we believe. So that's the idea. But for the math to math, I'm just trying to be very careful in implementing it. Because it's using geometry as like a basis to formulate the equations relative to these definitions and these ideas, and then tying it together with physics and the formulas and principles and fundamentals that we've known to hold true through our own observations, through our own experiments, through our own history, right? Because even as we observe the universe and everything else, especially as we explore quantum mechanics and we utilize the same structures of electromagnetism to find out more about it, there's the same theories from chemistry using it from that tier, that realm, and going down to the quantum realm and applying that, we're finding out so much more. Anyways, I'll be right back. Alright, I'm back. Jesus. So where was I? Where was I? I was explaining a lot. I was yapping. I know the stream's like blah, but whatever. Friggin' yeah. So x and y. So this is if x equals y. Substitute in x. If I substitute in, if I can get t to one side, substitute in r. Keep t factored out here. So let's factor this back out. Go backwards. So it should be 2, what was it, x minus t over 4? 2. 2. Oops. 2 the power of 2. Because it'd be 2 instances of that. Because if this was, if r was x and I was x, then it would just be these two plus together. And it should be this. I mean, when you factor this out, anyways, it should be that. So I didn't even move anything from here. I just did that, did some replacement, and kind of going in circles. But t over square root 2 times 2. So I could multiply both sides. I mean, or if I wanted this equal to r, could do that. Because I mean, well, that's equals r. This side's supposed to be squared, isn't it? Yeah, r squared. That's where I messed up. See if I can squeeze it in here, kind of. Sure. See, this is why I want to be careful, because I can't really just go back easily. I could take the square root of both sides from here. If that is the case. Actually, now that I think about it, interesting. Oops. Hmm. It's just hard too, because this is all friggin' MS Paint. But I could take the square root of both sides, substitute an r here, and then r would equal this whole bit. This is if x equals r. So on the timeline here, this isn't including z yet, which z is, that's the complexity of the thing. That's not going to be equal to r and I. Because if we look at things from the perspective the simple way, this is linear. But when we add the complexity, that's when everything gets all skewed. So let's do the square root. Because, I mean, square root of this, it should be square root of 2 times x. Or I can... No, I can't multiply out 2. I mean, I could multiply this out, but then I won't be able to take the square root either. I could just divide both sides, and then take the square root. It should be... Well, if I took the square root of 2 times that, square root of that plus that... No, it's not plus, it's times. Yeah, because I would just factor this out to the front. Alright, so that should be square root 2 times, well, x minus t over 2 equals t over square root of 2 . That would cancel each other out. Oh, actually, interesting. I mean, I could substitute an r at that point. T. Then it could be like equals r. Oh, forgot the times 2 part here. Times 2 equals r. Right? Could do that. Then let's see. I could also do this minus t over 2. We divide both sides, or well, all three sides, by the square root of 2 should equal... Oh no, I got double the square root of 2 here. Okay, interesting. Yeah, because then it would be t... So square root of 2 times the square root of 2 is 2? No. 2 square root 2? Hold on. It is 2. Okay, so that... Yeah. So 2 times 2, that's t over 4. Yeah. Equals r over square root of 2. Right, because again, we're dividing all three. I'm only putting equals r square root of 2 because this step right here, you can place an r for that. So from that path, we have a little bit different relativity here. And we have t over 4, so a quarter of the timeline plus half the timeline equals x. Interesting. I am trying to do a lot at once in my head, but... we freed this. Yeah, square root of 2 times square root of 2. 2, and then 2 times 2 is 4. R square root of 2. Also trying to remember, I mean, what was it? Pi r squared equals a equals e, so e over pi squared or square root of e over pi equals r. A couple things we might be able to do from this point if we substitute in the area for r relative to time. So if t over 4 equals that, which is interesting because r equals t squared root of 2, this is kind of backwards from that. Maybe I'm trying to do too much at once. See, I could solve for x. So x would equal, with this setup, if I'm right, t over 2 plus t over 4, which is weird. Because I'd be adding t over 2 to both sides. But relative, well, x relative to t, so about 3/4, right? So that would be 1/2, maybe 2/4. So, I mean, x could equal 3t over 4. 3t over 4. If that's the case. But then, if I, given in mind this step here, if I substitute in for r square root of e over pi, that would equal t over 4. Or I can do that even back here and then rework this side. Would I be correct in doing that? I think so, yes. Because then we have x, e, and pi. E would be a total number, the area. Pi would be a total number, well, the number, obviously. So we take out the variable r, be a constant. I mean, e is, well, the area is variable depending on the time that we're measuring or what we're observing, but in this case, it's a little different. So leave that here. I'll do a second thing here. Excuse me. So I'm curious to see. So we also have square root of 2 times x minus t over 2 equals r, because we're doing it from the equation of a circle. Now, if we substitute in r for root of 2 times x minus t over 2 equals square root of e over pi. E over pi is where things kind of get a little interesting. Because I can square both sides, and then we'll go back to the 2 e over pi. Interesting. If x is 3t over 4 minus t over 2, so that would be t over 2. No, t over 4. Huh. Perhaps? I don't know. This is a weird rabbit hole. But I'm wondering if any of this does actually make sense. Let's see. So if I squared both sides, means square root of 2, that's just 2 times x minus t over 2. That's still squared. 2 equals e over pi. This is the radius relative to the area. And then multiply both sides by pi. So get 2 pi times x minus t over 2 squared equals e. And I mean, e equals mc squared, or e in this case is the area, so pi r squared. And then that should obviously end up being that. Now from here, if we worked out the equation back out to this point, we have some more numbers. Then we would have what? 4 pi x squared minus 4xt, or 4 pi xt plus pi t over pi t squared. And that would equal e. So, I'll be right back again. Oh man. This whole bit of mumbo jumbo. We've been doing this for 3 hours. I don't know if I've gotten much of anywhere yet, but let's see. Let's factor this out and then multiply that in. So go back. Or let me just double check. Easy way to do that. X minus 2 power of 2. Sure. Okay, yeah. So t over half. That should 2 pi times x power 2 minus t of x. T-axis. T of x. That would be 1/2 minus 1/2, so that should be 2, and that would cancel out to that. Yep. T of x plus, so minus t over 2 times minus t over 2, that's t over 4. Correcto mundo? And then you do the 2 pi, and that would be equal to e in this case, and then, so it'd be 2 pi x to the power of 2. Let's do this. Minus 2 pi times t of x, or tx, plus pi t over 2. Sure. Equals e. Now t could substitute in r for t. I mean, E is the area of the circle. Reason and intent. T is one timeline. And if we put in 1 for t, for the entire timeline, E being the total amount of energy at the moment of the Big Bang, then we could solve for X and then also solve for Y respectively, because the reason and intent would be like that. Okay, this is something to consider. This is why it's all theorizing too, because I'm theorizing from this and the whole idea. Trying to find and explore different values for these numbers to see what we can do with this. So, boom, 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 t equals 1. We have this equation, we have this, x equals 3t over 4, 3 over 4 times t. So 3/4 of t equals x. Which, I mean, that makes sense, because if we move this line over here, and say that's about 3/4. 3/4 of that should be x. Especially as we see this as 1, 1, and then c squared. And that should equal, yeah, 1 plus 1 equals 2. And then 2 needs to equal that, or 1/2 t. Probably what, I don't know. Unless I could have screwed up somewhere along here, but I'm not sure. I mean, substituting in values willy-nilly like that, But at least, I mean, like I was saying with this, that equals that. So that should be substitutable in this instance. So it's all relative to the measurements here that we did of the timeline, taking into account, like, a circle in a box. So that's how we're doing this relativity. And then that's very similar to, I mean, 1 times 1, that's 1. It's the area, the unit area of the box itself, one whole universe, right? And then all the energy that is allowed to exist at that point in time. And it would be bounded in such a way. Because even with the universe, we still have about, say, maybe a quarter, or the difference of this area relative to the area of the circle. So the x times x. Because, I mean, these values are equal following a line. And then we have Pythagorean's theorem. So I want to do another one. So t relative to I and r. So using Pythagorean's theorem again. So if we know x, so from 0 to 1, we're just doing x equals 1, y equals 1, t equals c to the power 2. And think about those 1 values. Even if it's 1 squared, it's still 1. So this is why this is also interesting, because then Pythagorean's theorem, it's 1 squared plus 1 squared equals c squared, and c squared being t. So I mean, that's 1 plus 1 equals, we wouldn't say equals t, it'd be, c squared. Oh no, t would equal c, my bad. Yep. That'd be t squared, really. So I could do that. Because t is the hypotenuse in this case, looking at it like this. And then that would be 2 equals t to the power of 2. And then be the square root of 2 equals t. Square root of 2 equals t. It'd be like about 1.41. Yeah. That would be that. But if t equals 1, this is if obviously I and x equals 1. And then there's 3 times the square root of 2 over 4. So 3 times square root, or I should do 3 over 4 times, whoops, square root of 2. It's not 1. It's close, but no. So that doesn't align properly. Let's enter 1.06066017178. So yeah, this part, well, this is if x equals 1. T. It's not exact. Slight difference. So I did screw up probably somewhere here. That difference might be significant in understanding. Probably didn't cancel out and multiply this correctly. If we did, there's one timeline. Well, this is measuring relative to I and R. Maybe 1.06. Maybe that's relative to some extent. Like that, basically like 6% over, I'm gonna say, is relative to something. Because I mean, that's that. And I mean the area of the square is 1. The area of the circle, if R is, so go over here, the area of the circle, so A, different color, green, A equals pi R power of 2. Now, if R is, I would say, a portion of T relative to I and R being 1 at this time that's being measured, so we have R being relative to X, and then T is the square root of 2 in this framework. Because that should be kind of a definite, but not really. This is a square root of 2 is relative to X. I was saying, the area of this square is 1, but 1 whole universe. The area of the circle relative to that is different, where D is one side of the square, and then the circle 1/2. So I mean R would be 1/2. Duh. So R equals 1/2, and that just should be pi times 1/4, and that's it. Just pi times 1/4, and you can just calculate that, but that equals A. And then the difference, so A of C minus A of U, because the framework being 1 whole universe, and then the forces are surrounding what exists. Yeah, A of C. Alright, A of E minus A of U. So this would be, let's do A of E, E being the circle. So this, well, I could probably change the order of this so it's a positive number. I mean, the bigger one too as well. A of U minus A of E. So this would be pi, or 1/4 pi, or I'll just do pi over 4. Pi over 4 minus 1. Or no, 1 minus pi over 4, my bad. 1 minus pi over 4. What is 1 minus pi over 4? One minus pi over 4. Oh, 21.5%. I want to say. So it's the difference in the area of the circle relative to the square. 0. So using sig figs about, let's just do 0.215. There's a number that we do see. 0.215. About. Alright. So let's figure out some constants here too, to help with the rest of this analysis. That'd be great. Because we do have pi. We do have values of 0 to 1. Keep it simplified. Whether something's true or not. to values on the axes that we can use. And then, granted, whatever the position is for everything else here, it depends. I mean, A also doesn't have to be 1, it just depends on, again, the numbers that we're putting in here. But 1 minus pi over 4 is 0.215. So 2 of that. That's definitely the difference in area. You divide that by 4, then we get the area of each of these, respectively. So 0.215. I'll go back here. Divide by 4. So 0.054. Yeah. So 0.054 equals 0.054. And again, approximately. So about 5%, or about 5.5% amount of energy required to shape or change something that exists right after the Big Bang into not to break it down compared to the energy that's available in the entire universe at that point in time. So say, I guess a planet or a star. Well, I want to say a planet. I mean, stars definitely do have much more integrity than like asteroids, rock, and solid matter. Um, I mean, yeah, they're just active energy reactors that go and go and go and go and go basically forever. This is interesting. It's about 22% of the area. Difference is here, and then a quarter of that would be here. So we're getting different values here, and then obviously when this moves, this is going to change relative to that, this quarter measurement from that base beginning with t equal 1, or well, t equals square root of 2, when r and I equal 1, reason intent for the universe existing. Now, if t equals 1, the math is a little different. So, just for one timeline, I mean, it's 3t over 4 x, 3/4 of x. No, it's probably some weird numbers or something here. I don't know yet, but definitely more to explore. Um, Probably gonna switch to doing something else though for now, because I don't know. I don't know what else to really explore at this point in time necessarily. Because clearly there's some more that I gotta look into. Just analyzing this instance. Hmm. I guess that, yeah. That value must have some importance to something. I just can't think of it off the top of my head. Hmm. Have that. Now I need to figure out what h and k would be as variables. Or, well, if h and k were each x, or relative to x, I think that might be where the substitution that I can also try as well. So not this x equals 3t over 4. Maybe that's where I screwed up. Instead of substituting in h and k relative to t, do it relative to x. So then we can condense the y values as well if y equals x, following this timeline. So t would still be on this side, but we would rework the equation. Instead of having t here for t here, it would just be x relative to the radius. So, I mean, 1/2, as we can see right here, this instance, 1/2 x is the midpoint. All right, so that's, all right, that might be where I'm screwing some things up too. It was just how I'm approaching this. So I guess one last expansion. So let me, excuse me, brain. So we go back to x minus, it'd be x over 2, then squared, it'd be 2 times that as well, because it'd be plus itself if y equals x, going back to the statements from before, over 2 equals, so t over square root of 2. I got a little mess up there too, whatever. That would be equal to, yeah, t over square root of 2 times 2 triple parentheses this thing, because this is t relative to the radius, which the radius is relative to x, like as x over 2. Granted, it's relative to the midpoint, which is the formula that we're using here. So this, and then this is squared. So both of those sides are squared. So we take the square root of both sides, and we can start doing math. So that'd be what? Square root of 2 times x minus x over 2 equals t over square root of 2 times 2. Let's do this. Okay. When I have that, I can multiply both sides by square root of 2 over 2 to get t relative to x this way. And then x is relative to r based on being, I mean, x equals d, the diameter of the circle at this instance. So therefore 1/2 x equals r. Um, So square root of 2 times square root of 2 is 2. And then times 2 again is 4. But would I have to factor this? No, I don't think so. It should be 8 at that point. 8 times x minus x over 2 equals t. So multiply both sides by square root of 2. That would be, yeah, because I could do it step by step. I don't have to do it all at once anyways. But all at once would be 8. Alright. That should work out like that. So it'd be 2, no, it'd be 4 actually, not 8 then. Square root of 2 times 2 is 4. No, not 4, it's 2. And then 2 times 2 is 4. So 4x minus x over 2 equals t. So that would cancel out on that side. I mean, I could do x minus x over 2 equals x over 2. And just do the math there inside the factored form. I mean, it's going to break down anyways to that. Even if I factor in this 4, then that would still be, whoops. That'd still be friggin' 4x minus 2x. Actually, 2x equals t. And then that would be 2x equals t. In that case, can you divide? No, it doesn't make any sense though. Because t is not the radius. So what the fuck did I do? Huh. But I think that is how you're supposed to do that. It's 4 times x, and then 4 times that. And 4x minus 2x, that should be 2x, equals t. And then x equals t over 2. And that is completely different than the x equals 3t over 4, which that makes a little bit more sense. But t over 2, that would be in regards to the radius and not the timeline. Somewhere math ain't mathin'. Trying to think as well. Let me put the original statement that x equals t equals r over, or, well, equals 2r. Duh. Alright, wait. Alright. X equals d equals 2r, right? And then be equal. In this case, we were looking for, well, no, it wouldn't be equal. It'd be, we could just separate this kind of. So I want to do h equals, because the midpoint should be 1/2 x, or x over 2, and then k equals y over 2. If the midpoint depends on the radius for those two variables of reason and intent. So that's what it should be, as whatever x is in the scale would be relative to the diameter of the circle in this graph, just this graph specifically, because this isn't, because I mean, the normal graph of a circle, if it was the center point was the origin, it would be just x squared plus y squared equals r squared. So similar to Pythagorean's theorem, in a sense, because it kind of cuts everything in the right triangles anyways, but there's a little bit of pi involved, kind of, and just the structure of the equation. But in terms of, which actually, speaking of which, I don't see pi anywhere in the equation of the circle. I don't know. Hmm. That's if x equals, well, h equals x half, and then again, x equals I, r equals y. Going back to up here somewhere. Kind of, and then in respect to the timeline, our x, because these values are the same, it would, the midpoint would move along the timeline, which is kind of like the not the, well, the animation, essentially the simulation that this model should be representing is that the half-life depends obviously on what's left in existence and the complexity. And then obviously the bounds will fall along that midpoint, and they'll start clamping in closer and closer as less and less time is remaining in the universe, as time tends toward zero. Through this perspective, granted, typically we measure time as the difference of position or just movement, or it's a difference from when I say one word to the next, basically. So, but to try to model these variables in such a way that they commute and work together to model in the 2D perspective what a change in x or y or t would look like, because changing the amount of time would reflect what the radius would be, would reflect what the x and y values are going to be in this simulation of consciousness, of thinking. So it's like when you have an initial thought, this is all the energy that's expended in that, and as you go over it and realize that thought into reality, it goes from imagination to here to existence, and then from existence to possibility, impossibility once it's realized, and then it starts going into extinction as it gets used up as a resource or worn down through decay and everything else. It's just depends on the actions that you're observing and measuring. So, hmm. So yeah, x equals 3 over 4t. This must be a mistake, maybe, or I'm just not relating the equation in the right way. And this is where, yeah, k equals y over 2, and then I substitute in x for y, because they'll be equal to each other relative to reality along the timeline. And that's how the midpoint's going to move, as if x is equal to y. Otherwise, if they're different, then you're going to have different midpoints, and the circle's going to be not following reality. It's going to be skewed. But when it comes to what exists within the circle, that's okay, because it all eventually follows the timeline. It follows exponentially going down, so kind of like graph from here. If something's over here, it'll whoop, whoop, and then if it's up here, then it'll just whoop, whoop. So it'll be different, and that's, I guess, where the 3D comes into play. Maybe this is what this era comes from, was the difference in perspective. I don't know, but square root of 2, so 1.4. Let me just put down that value anyways because it keeps showing up. So square root of 2. Yeah, 1.414. I know it's relevant somewhere. So 1.414 equals square root 2. This is approximately. So that's something to keep in mind as a scale. Because this is basically the square root of 2 is a scalar relative to this whole framework. Same thing with the pi over 4, or the 0.215 over 4, or the 0.215. That's a scalar in this. So trying to derive all these different parts. So if x is 1, yep, and then, yep, this is the big triangle. So we have t from the perspective of the big triangle. We have t from the perspective of half of it. So 1/2 t should be square root of 2 over 2. We divide both sides by 2. But as we see here, maybe this is where I screwed up. R equals t over the square root of 2 times 2. But this t does not equal this t. But, well, no, actually, wait a minute. Maybe they're just two different t's. Because if I substitute in square root of 2 here, it would be 1/2. R is 1/2 the diameter. So that's right. In terms of looking at x equals 1, y equals 1. So timeline from that perspective does work. And then, yeah, because t would be r times square root of 2 times 2. Obviously, r is half the diameter. That does actually, yeah, wait a minute, yeah. Relative to x and r, relative to the diameter here, that does work. When we substitute in the proper values and considerations. Because, yeah, r is 1/2 d. And then those two multiply both sides by 2, that would cancel out. T equals, or well, d equals t over the square root of 2. And that would make sense here. So let me do, that means d equals t over square root of 2. Okay. I mean, just by definition, because diameter is twice the radius, multiply both sides by 2. That makes sense. Okay. And then d, oops. and then d equals x equals y, as I think I stated over yonder. Well, a equals b equals r, but d equals x equals y, and that's right here. Okay. At just this specific moment, if the values are different, then we have to plug in obviously different values. And that would determine the diameter would be different, obviously, in scale. The radius would be different, therefore the total amount of energy, all that other stuff. So we have all that. Now the other thing is if d equals x here, so d equals 3 over t, or 3t over 4, substitute in d for 2r, so then you would divide both sides by 2, and then that would be 3t over 8 equals r. That is interesting. Because this is x equals y in the equation of a circle, we get this result, which I'm going to have to double check. Because, I mean, so far, and this is relative to the area. So let me do some boxes. Let's see. Do that here. Right. That's nice and separated. This is all screwed up, so oh well. That. And then I want to do this as well. Yep. This. Yeah, I have r equals 1/2 there as well. And then this here. Alrighty. Makes that neater. One. Oops. Let me do that. That. We do a smaller size. 14. So percent. We'll stick with percentages. In fact, hold on. Let me even smaller size. Do an 11. It'll be 100%. Over here also 100%. So it's like, say if you wanted to destroy the entire universe right after the Big Bang, right? You would need to 100% intend to do so, 100% have the reason to do so, and need the total amount of energy required to do so. Now, I mean, following for every action is an equal and opposite reaction, the laws of thermodynamics and stuff like that, you need the same amount of energy to cancel out the Big Bang, which, I mean, I guess technically happens the moment after the Big Bang happens, which is what allows everything that's made at that point in time that's compressed down to exist. So, explaining why, like, granted, at the Big Freeze, the true Big Freeze, nothing exists anymore, or, well, nothing exists anymore really in terms of mass. There's no mass available. Energy is just non-existent in terms of activity, in terms of state, but the fundamental particles that described, that reflected that energy that did exist as space is created further and further and further. If even like all the black holes are all evaporated down to nothing, which this is like probably trillions or maybe even quadrillions, almost an infinitesimal amount of time compared to our own existence. With that in mind, like the big freeze for that, we wouldn't be able to experience it, we wouldn't be able to really measure it. This is our best estimate as to what is going to happen with the levels of entropy that we experience through our nuclear fusion reactions and just chemical reactions and stuff like that. Stuff on the small scale, where this is analysis of the large scale, with again the perspective of the universe. So, even though this looks like a little circle on Microsoft Paint, this is what the universe would look like from the perspective of the universe. This is how the universe sees the boundaries since the Big Bang. It all does evolve into a circle. And like the previous graph, I mean, granted, it's counterintuitive, the flow of actions relative to the flow of time. How we view time is clockwise, but the flow of actions is counterclockwise. This graph as well, granted, this completely fills the bounds and stuff like that, but the distance of the universe from one object to another right after the Big Bang, obviously they're still like neck and neck. They're still like right next to each other. Just like again back to the shrapnel and grenade analysis. Like a millisecond after the grenade goes off, like the bits are still like localized where the explosion, the center of the explosion is at that freeze frame, but they've obviously moved distance. There's displacement. So when we analyze what the universe in total would look like at that point in time, the total condensed energy, I mean, to explain it would have to be a big circle because this is where all that energy is concentrated in one spot. But clearly it's all happening in this like little center midpoint of interaction. It's in a 3D plane as reality exists in 3D, but we measure in all sorts of dimensions in order to derive a better understanding behind the reality, behind existence. That's what we've been doing for ages and years. This is, again, using simplified math, kind of going from the perspective of the universe. Granted, this is big circle, but clearly as the universe expands, this circle is getting smaller. So again, it's following the flow of actions, which is counter the flow of time, which is counter our intuition with how we perceive things, how we measure things. But it does, like the inverse, does correlate to extinction, to the change that we observe, the expansion of the universe, for instance, the space that's added in between objects, which is why that inverse of all this explains the flow of time in a weird way. This is why when we went over the concept with Brock on Twitter, it was stuck on this whole idea of chaos, but chaos comes from misunderstanding, and the misunderstanding comes from how counterintuitive this whole concept is. But take the inverse of that. You take the inverse of this chaos, this amount of energy that all exists that we don't comprehend, that we don't get to experience, or anything, right? All that chaos that happens at that point in time, the Big Bang, because that is genuinely the biggest moment of chaos that occurs, the biggest moment of uncertainty, because it's all the particles that are all fundamental particles, are all uniform. They're all photons at that point, massless. They just reflect whatever is nearby, but if there's nothing nearby, there's something to reflect, and there's nothing with that field that's left. The cosmic microwave background is entropic, it's done. It's all just one plane bouncing off the plane of photons, and there's only one way for it to go. So when all those fundamental particles that we are now learning about, even more so, when all those collapse onto themselves to reform matter, as that is probably really the only way, because the most amount of energy that exists, which theoretically would be infinitesimal, but realistically is dependent on the amount of mass that exists at any point in time. So, or mass energy. Granted, this is, again, the moment of the Big Bang, so time is, you can say, a Planck length, or maybe even smaller. That part, I don't know yet. When we start looking at h-bar and Planck and all that other stuff, maybe we can see what we can do with that. But regardless, at the moment of the Big Bang, all of it is condensed back into matter, because that is the only way for it to go. That would be the only way to explain the Big Bang itself. As, I mean, as we experience, something doesn't come from nothing, necessarily. But following this whole idea and this four-quadrant system, just looking at the one quadrant of existence, trying to derive these factors, so then when we look at extinction, we take the inverse to find out the relativity of space and mass energy, right? To understand the collective of particles, spin, and force that make up space, that is the history of what used to be there. Whether it's celestial bodies shedding off the energy into space through reactions from themselves, just like how hydrogen and other atoms escape our atmosphere all the time. Same thing with the sun and all these different atoms and molecules at a chemical level make up space, and then they end up interacting when you start looking at things at that realm. So it's interesting, because we clearly do have free particles in space. They do end up reacting eventually with stuff, other free particles in space, or other celestial bodies, or maybe even black holes. That's where probability and possibility comes into play. The uncertainty principle and stuff like that. That's why we have an uncertainty principle, because as human beings, we are not certain about our measurements, because we can't fundamentally look at everything like the universe can. So this idea takes out that uncertainty principle, but there still is probability and possibility relative to what is left in existence, and there's always going to be uncertainty when measuring from one point in time to a future point in time. But there's more certainty when you measure from the present to the past to stuff that we already know because we've experienced it in some way. And typically with scientists and obviously with physics and laws of physics and fundamentals like that, clearly those have withstood the test of time. So there's more certainty with those measurements in a weird way. Clearly with quantum mechanics, we can't analyze quantum space and observe it in such a way, so that's why that uncertainty principle is important. But at the same time, in that realm, in that micro level, just like in the macro level, how we don't understand the acceleration of the expansion of the universe, it plays a role. Because again, as more and more things break down fundamentally, they get easier to break down. Whether or not they're further away from each other to interact with stuff, regardless, time has already passed. They're already whittled down because of just the internal decay and reactions. Like for every star, obviously it's burning fuel every second of the day, every second of existence. Every moment that passes, more and more atoms are being broken down and released into space from every single star in the universe, right? And then the planets, the solids, the meteors, the comets, and all that other stuff, they all interact with those stars, and that hastens the breakdown. Or if they interact with other planetary masses, which hastens the breakdown because it breaks things down even further. We're not creating anything else that's really new, especially at this point when we've harnessed atomical energy to the extreme, and the amount of energy that's within atomic bonds to a point where we're able to modify elements, space, existence. I mean, nuclear bombs, for instance, as well as, like, to me at least, a nuclear bomb is basically a miniature black hole with the amount of energy that is released. And how I imagine black holes, granted, yes, they release radiation, right? Same thing with nuclear bombs and explosions. Black holes is a collapse of the nuclear fusion and fission that occurs within a star once it runs out of a certain element, right? I think it was the helium or hydrogen or whatever is all burnt out. There's clearly like still atoms and plasma and stuff. There's temperature, everything else. So where does that interaction? What happens with those interactions when the least restrictive path of stability is gone, right? When the balance is taken out, then those other atoms are left to interact because they're all taking up within the same space. And when that happens, when there's nothing in between them to slow it down or to prevent them from reacting, we get, depending on the mass of the celestial body, we get black holes or nebula stars. Because there's a threshold that's experienced, as we've observed, where there's a formation of a black hole or a formation of a neutron star. And that threshold is relative to existence and extinction, as well as entropy and reaction. It's the limit of how many reactions can occur within a point in space and time. So clearly, if a celestial body is so big in mass and energy, but it runs out of the stable elements that kept it going for a long period of time, and then it goes toward its end of its life, and it starts changing, it's all within a point of space-time, and when it collapses, the density of the reaction that occurs just collectively, the sum of all the little reactions that are occurring in that point in space-time, because they're all rushing to the center, they're all rushing to react. They're not necessarily rushing to the neighbors, they're rushing to the hottest point, which is the center of a star, because that's in the middle of all the heat. That's, again, thermodynamics and, well, the lack of insulation at that point, because the freaking star. What's the hottest point of the star? You would think the center, just like the hottest point of our planet is the core of the Earth, right? And same thing comes to the singularity in a black hole, as we've observed with smaller black holes that don't have the outer shell of non-reactive materials, or materials that aren't reaching the center fast enough. There's like, it's colder on the outside for the bigger black holes than it is in the center, and as we experience with smaller black holes, they're much hotter. That is relative to this whole idea and measurement, that, and the idea of the threshold where a black hole goes from, well, not a black hole, where a celestial body goes from either a nebulous star or a black hole. So it's interesting, and as a way to model this, not using, I mean, we're not applying other theories yet into this model. First, we need to be able to model, using the equation of a circle, the movement of the midpoint of the circle relative to the area along time, right? So from, and this is why we're starting at the moment of the Big Bang, when it's expanded to the maximum, because the values are much more simpler to work with. You 1 to 1, and it's relative to the one entire timeline, 100%, no percentage value yet. So simple numbers, and if we can get the model with the area relative to the amount of mass energy that exists at the moment of the Big Bang, right? And then to model the movement of the midpoint of this circle alongside the change of that mass energy throughout time, as that mass energy goes toward entropy and makes up space and continues to build space between everything. So moving from the realm of existence to extinction to the nothingness of space that is space. Then with that model, with the equal and opposite being the inverse, and then perpendicularly you have possibility and impossibility, possibility relative to probability, and impossibility relative to improbability, depending on what's left in existence or what's doesn't exist anymore, what isn't available as a resource, because that would be, I wouldn't want to say the, well, it would be the opposite as well as the inverse. So again, it would explain the quadrants and be able to model all 4 quadrants at the same time, working tangentially, or, well, like, as this existence lowers, less possibility lowers following along that, but just, well, I wouldn't want to say with a slight variation. It should go basically 1 to 1. The slight variation is just, I guess, the moment that passes, right? Because clearly, for imagination, for probability to take place in existence, time needs to pass. That unit of time depends probably on the complexity of things as well, maybe in the 3-dimensional realm. So, and then the same thing with impossibility, the less it's available, then the bigger impossibility gets, and then until this becomes nothing and the other side becomes everything. So, yeah. Alrighty. Jesus. Oh, well, they left. Yeah, nothing really was going on. God damn it. It's tough being a person sometimes. Or at least a streamer. It definitely is a streamer. Like, unless you have, like, absolute free time, then it's like shit. I mean, granted, this is freaking math. This is, like, definitely the least interesting thing in the world. And, well, algebra and trying to replace different values with different values to make a model. Hmm. Well, let's see. Well, I have x. Yeah, I'm gonna have to do some pondering over this because I'm gonna have to not just relate. I mean, h and k to x and y because we want to also be able to model in the 3D for the z, but not even just that. But say if x and y are not equal, I need to be able to model h and k respectively to each of those variables. as the midpoint relative to the radius. So if it's not a perfect circle, then it would be an ellipse and it's going to be all weird because it would be bound in here, but clearly, like, say if the midpoint was relative to x and y, so reason and intent, if the midpoint was moved over here, then clearly the shape would be weird, especially stuck in this framework with the total amount of energy, which is probably explains why reality is on a timeline and doesn't just bend and curve like we think, but maybe this will be a model to explain how space and time bends because of black holes. Maybe the curvature of a freaking event horizon or something. I don't know. But I do want to be able to match x with h and then y with k relative to the timeline, which is relative to the area of the circle or the amount of energy. Because even if the energy isn't in the shape of a circle like this, if there's some force that's acting on it that's bending it differently, the amount of energy is still going to be the same. It's just going to be the shape's going to be different. And that's where complexity starts really coming into play. So, well, yeah. But this is at least model that, and then we can start modeling from this relationship once I work on that equation of a circle and everything else. Modeling this to, yeah, like I said, I got the area here. So B equals that. So if I do have this, equals the area. I have T here and I have X here. I wonder if anyone's even calculated total amount of energy of the Big Bang. Did anyone calculate that? What? Oh. Oh. But then you have this here. E over, what the fuck? E naught. So, the hell? Was it gravity? Hmm. Well, positive and negative energies in this theory, it's theory, conservation of energy. This balancing act means the total net energy of the universe has always been and continues to be zero. I mean, yeah, that's what we're trying to measure both sides because clearly they're going to balance out. Existence and extinction balances out. Formation from nothing, yeah, or empty space, yeah. Without the need for a separate power source, violation of fundamental physics. That's the transfer from the big freeze to the Big Bang. Cosmic inflation, a period of rapid expansion in the early universe. Potential energy from the inflation field was converted into the mass and energy of the particles that make up the universe. Interesting. Process of cosmic inflation is thought to balance out the negative potential energy of gravity, leading to a universe with a net energy of. It's like the shrapnel interacting with other shrapnel from the grenade example. Implications: no external power source. The zero energy model explains how the universe could expand. Universe without a creator provides a way to think about a universe emerging from a state with no energy, which is a concept consistent with our current understanding of physics. Yes, it is, but I'm trying to model that. So what's this? flow. And I open image in new tab. What the hell is this? E naught over 2 equals nms c squared. N equals E naught 2 ms c squared. 10 to the 68 joules. There's a shit ton of energy divided by 2 times mass times the speed of light. Oh, this is the amount of stars. Oh. 139 quintillion stars. Newton, this is the force? Bug flying around my face. What the hell? Interesting, okay. Mass. Energy? Oh, it's the same freaking. Moment after. Consider to be infinite because it's spatially infinite. For a spatially infinite universe, the Big Bang represented the phase transition, so the total mass and energy has always been infinite. However, if the universe is not infinite, then the mass and energy might have been finite, but this is less supported by current observations. It's definitely finite because there's a beginning and end. It's just the number is extremely hard to conceptualize. Context of general relativity in the expanding universe, there isn't a robust definition for the total energy. Well, it's one trying to figure out. And dark energy, which drives the universe's acceleration expansion, is not well understood, making it difficult. This is also what I'm trying to explain. Mass is not conserved. Yeah, no shit. Yep. Yep. Yeah, that's the whole principle and idea. Flat universe, observation says the universe is flat, which supports the idea of an infinite universe rather than a closed one that would eventually collapse. It'll collapse when nothing's left, but it's not going to last infinitely. Instead of the total amount, cosmologists focus on the density of matter and energy per unit volume. This density decreases over time as the universe expands and the existing matter and energy gets spread over larger space. Redshift. Amount of mass. It's definitely not definitely known. Yeah, no shit. But the mass of the observable universe is approximately figure determined by the universe's critical density and volume. The universe began as mostly energy, which converted into mass and continues to expand and cool. Yes, it does. That's exactly what I'm saying. Okay. But the mass of the observable universe is approximately that much. Infinite versus finite. The answer depends on whether the entire universe is infinite or if we are considering only the observable universe. It all comes from the center point, though. So where's the center? The center of the universe should be the supermassive black hole in the center of everything. center of the universe. Scientific center of the universe, according to the Big Bang Theory, the universe expanded everywhere at once, meaning the expansion has no central point, and thus everywhere can be considered a center, while historical beliefs centered the Earth or no. I want to say the biggest black hole probably would be the center, because they're all gonna work toward. Most massive black hole discovered to date is an object in the cosmic horseshoe galaxy, confirmed to have a mass of about 36 billion times the sun's mass. Times 16. Remains a contender with an even higher estimated mass. It is twice the amount of the mass, but with higher observational uncertainty. Okay, so it's further away. The cosmic horseshoe black hole is an ultramassive black hole whose immense gravity is confirmed by the gravitational lensing of a background galaxy, providing strong evidence for its mass. Ultramassive black hole. In a quasar meaning is actively accreting mass. Are defined by massive sizes with masses ranging from tens of billions to over 10 billion solar masses. But then you have one that's almost twice the size, theoretically. Hmm. Yeah, I do want to say that wherever the largest black hole is, must be the center in some way, shape, or form. Because it should, I mean, again, by the whole idea of just expansion from a central point. Because the Big Bang, I mean, for all that energy to collapse, for all the particles to come back together, from the nothing that is obviously theorized to turn into something, it needs to be condensed. That's just how it works. There needs to be a force that condenses all that potential energy, which is space at this point. Because that's all potential energy for the next universe, the next iteration. So there has to be a way that, again, like I said, the true vacuum is realized as the false vacuum. So big freeze to false vacuum to Big Bang. Describes a potential sequence where a dying universe in a big freeze state could undergo a false vacuum decay, leading to a new state that could, under some speculative theories like conformal cyclic cosmology, begin a new Big Bang. This theory, known as eternal inflation or cyclical universe, suggests that a big freeze or heat death is an inevitable. Yes, 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 yes. But a transition to a lower energy state, true vacuum, via false vacuum decay could restart the cycle. This is exactly how I'm seeing it. Yes, it's a theory, but this is where we see the universe ending up. Even, for instance, like, even say if all baryonic matter was broken down or absorbed by a black hole. Even the black hole, like the supermassive ton 18, if that ends up getting bigger and swallowing up every other black hole in space for whatever reason, say if that even happens, there's still something that exists that's going on. I wouldn't necessarily want to go so quick as, oh, that black hole is the next universe. No, that is just a series of reactions happening within a point of space time, accelerating. And they're all fighting to react to the singularity where everything's occurring, where it's a maximum amount of heat, as heat excites molecules. And so, kind of like how the shells, each shell is cooler and cooler and cooler because it's more stasis further away from the singularity, just due to laws of thermodynamics and stuff like that. So, where the center is probably the hottest point, which I think, yeah. So, hottest center of a black hole. Center of a black hole itself, meaning the singularity, is not what becomes hot, it's the accretion disk of a superheated matter surrounding the black hole that reaches incredibly high temperatures. Really? With quasars representing some of the hottest regions in the universe through this process? Okay. The matter in the disk is accelerated to immense speeds, colliding and generating enormous heat. Oh, yeah, that's true. The event horizon, yeah. Creating the intensely bright and hot environments we observe. So, yeah, they accrete, yes, Fulton, so I was right about that. As matter approaches the black hole, its intense gravity accelerates it to near light speeds, collisions and frictions. While black holes themselves are theorized to be extremely cold based on the Hawking radiation, it is the surrounding hot accretion material and not the black hole's interior that we observe as extremely hot. Okay. Hmm. So what was it? Smaller black holes were hotter? Temperature of black holes. Sure. Black holes themselves are effectively at or near absolute zero in temperature, but this temperature is inversely proportional to their mass, meaning the more massive a black hole, the colder it is. This temperature refers to Hawking radiation, which is an incredibly faint emission of energy from the event horizon. In contrast, the material falling into a black hole known as an accretion disk can become millions or even billions of degrees hot due to friction and gravitational forces. The amount of this radiation is inversely proportional to the black hole's mass. Near absolute zero, because all known black holes are extremely massive, their effective temperatures are far colder than the cosmic microwave background radiation of the universe and are therefore near absolute zero. Like a giant stasis chamber. Well, how we measure the temperature is clearly the outside, like the blackness. And then you have the accretion disk, which, hmm, hmm, has to do with gravity. Yeah, temperature equals, huh, this is what I was referring to, though. Smaller black holes are hotter and more massive, larger than black holes. Oh, they're hotter and more massive, larger black holes are colder. Yeah, this is what I was saying. So I'm curious. I mean, the outside of like a small black hole hotter, granted accretion disk and stuff like that, the radiation emitted by a black hole is inversely proportional to its mass. Therefore, a large black hole has more dramatic curvature, resulting in less intense radiation, while a smaller one has more intense Hawking radiation, making it hotter and causing it to evaporate faster. So yeah, it's inversal. But what is the temperature of the singularity? Because I want to say maybe that's the inverse as well. Like it's the singularity is perhaps maybe a reflection of the accretion disk and the speed at which matter is moved along there. So I want to say it would be inversely toward the singularity because singularity is where everything's rushing to react. Because as we see, black holes do evaporate. They do have things going on inside of them. Hmm. Temperature of singularity. Yeah, it's definitely not well defined by current physics. A ring singularity. Okay. And where does the observer go? Temperature of a black hole singularity, not well defined by current physics, as it's a point where spacetime and our understanding of laws break down. While the singularity itself may be at or below absolute zero due to its compressed motionless state, black hole has a different calculable temperature related to Hawking radiation at its event horizon. Okay, yeah. Cool, guy in a wheelchair saw a big light. Hmm. Because the extremely dense compressed state implies a sensation of all molecular movement. But something is obviously occurring. Planck temperature. Another idea related to the breakdown of current physics is that the temperature could be in the range of Planck temperature. That's what I'm thinking, which represents a theoretical maximum temperature where our current physics breaks down. That's what I'm thinking. Is that because of how rotational torque and force works, so rotation of torque from the center compared to the speed, because clearly a black hole with the accretion disk, it's moving very fast, it's superheating things, but it's going around it, right? There's a gravitational rotation. So torque equation from center of mass. But rather relationship, yeah, that's what I mean. Objects tend to rotate around the center of mass, and the total torque acting on a system of particles is equal to the total mass times the acceleration of the center of mass, or the net torque. Yeah, that's kind of what I'm thinking. So I think that relationship might explain the spin of the accretion disk. The speed of accretion disk. Speed of an accretion disk varies the distance of the central object, reaching hundreds of kilometers per second for main sequence stars and approaching the speed of light for black holes, with speeds of over 10% the speed of light being possible. Wait a minute. 10% over the speed of light. So faster than the speed of light. But wait, what? How does that happen? So that must mean that, I mean, there's definitely a relationship with the center of the black hole, the singularity, and the accretion disk, both in temperature and speed as it relates to torque, especially if it can move things 10% faster than the speed of light. So that's pretty significant if that's the case. The materials within the disk accelerates as it spirals inward due to the central body's gravitational pull. Yeah, resulting in very high orbital velocities that are influenced by the disk viscous torques. So as I was trying to make that connection there. Distance from the central body. Yeah, material closer to the central object experiences faster, stronger, blah blah blah. Therefore orbits at a faster speed. The more massive and compact the central object, the stronger its gravity and the higher orbital speeds, potentially reaching relativistic velocities. Viscosity, viscous torques in the disk cause matter to lose angular momentum, allowing it to spiral inward and gain speed. Examples: around main sequence stars, the orbital speed can be hundreds of kilometers per second. Around black holes, the speed can be very high, sometimes exceeding 10%. So, for example, matter near a black hole's event horizon can reach speeds close to the speed of light. That's what I'm saying, yes. So close, and then speed limit of light being that, which I guess in the black hole, or at the actual surface of the black hole, it's faster than light, making it unobservable for us, which is why it's a black hole, and why we can't see anything happening inside of the black hole. But granted, bigger black holes have stasis on the outside. They're typically colder if they're bigger, and if they're smaller, as in, granted, how I see it is like it's insulation, right? It's all those chemicals and well, not chemical, all those atoms, because that's what they're spaghettifying into anyways, is atoms. They're fundamental particles in essence. As things enter a black hole, I mean, as a star itself is literally just a bunch of atoms interacting in plasma in space. They're not solid structure. The bonds are, it's different. It's much different than matter that it's physical because it's plasma. It's interacting differently because of the types of chemical, the types of atoms, etc. So if all of it collapses in on itself and is trying to at the same time react, because that's what it's doing, and it's fighting to react to the singularity at the what was the hottest point of the star, which I still think is the hottest point based on the equations of torque, as we just explained how the outside of the black hole, especially like, well, small ones and stuff, but at the speeds, excuse me, at the speeds that this is telling me right here, obviously going to the speed of light, very high temperatures, use thermodynamics and laws of movement and stuff like that for atoms to be going at that speed. I mean, this is what we do to do nuclear colliders and all this other stuff, right? Is that we're accelerating things close to the speed of light and colliding them. Black holes, this is happening all the time, therefore you get the temperature that you're getting. It's basically like nuclear explosions after nuclear explosions. constantly happening that makes up the quasar. So this is how I'm seeing it at this point. Now, that torque, that speed, that, say, like a hydrogen atom near or in the event horizon as close as possible to the black hole without entering the black hole, without passing through into the collection or density, whatever, if it can. Because, I mean, at that point, once you're going at that speed, you're annihilated. You're reacting with something, and whether or not you go through the black hole or anything, that you're not even going to be a human being, so, you know. But to measure using the event horizon and the speed to measure the temperature of the singularity, as, I mean, granted, yes, that's the densest part of the black hole, but at the same time, there's a reason why it's a black hole. There's a reason why it exists over time as a black hole, because everything's fighting to react, but it's fighting so hard that everything around it on the outside is in stasis, waiting for its turn to react, to become the Hawking radiation and the particles that are emitted that we observe. So that's why the Planck temperature, that makes more sense to me, following the laws of physics. Not saying that, I mean, a black hole, I guess, breaks our current understanding, kind of, if we don't follow this logical pathway of, well, the center probably isn't really in stasis, because as we observe, smaller black holes are at a higher temperature than larger ones. And with torque and how torque works in angular momentum from the singularity as a black hole spins relative to the event horizon, if the temperature at the center was absolute zero, then it shouldn't be really spinning at all. But it is. In fact, it's spinning to a point where we're getting 10% faster than the speed of light, apparently, or, well, up to the speed of light. So, because again, we observe, at least in the event horizon, around black holes, just in general, no matter the size of the black hole, it's still the speed of light. And where we also observe smaller black holes being hotter, I feel like that stasis of material, depending on the size and, I mean, the density of the black hole, is probably uniform at a certain point, right? It's probably at its limit. So, with that in mind, perhaps it's inverse to how we're observing it, just like how the size and the temperature is inverse to that of a star. Because what bigger star is hotter, right? I want to say, size of star, temperatures. Well, yeah, hotter is blue and coolest stars appear in red. Yeah, because then once it goes a certain thing, by size though. So the hottest O-type, blue, then blue, white, white, yellow. Okay, so that's the visual light scale. And then I guess once the outside gets so cold, I don't know. Luminosity, fusion, star's core temperature dictates the rate of nuclear fusion within it, which in turn influences its energy output. Again, Yeah, it's because the center runs out of fuel, then that's when it dies, and everything that's been floating around it kind of just fights to the center, and then nebula star black holes determine there. Especially hottest stars. Does hottest mean biggest? No, because we have red giants, but that might have to do with gravity as well. Mm, stars vary drastically in size, from smaller than Saturn dwarf stars to hypergiants, which is about okay. Our own sun, blah blah blah. I don't want a video. Dwarf stars are the smallest, and only a fraction, some being about the size of Saturn. Giant stars, red giants, supergiants, which can be hundreds of times. Hypergiants, largest stars. What color are those though? Stellar evolution. Most stars are about the size of the sun when they are born, but grow larger as they age, especially when they enter their giant phases. Hmm. Size of O-type star. Like a blue star. O-type main sequence stars typically have a radii 16, while O-type stars are the most massive of the main sequence, with masses ranging from okay. Their sizes are more modest in comparison. So the mass density, and obviously they're hotter and brighter because it's more dense, more reactions going, depending on probably the element. I mean, it's typically made of the same elements, kind of. I don't know. uh, no, yeah, yeah, size, yeah, yeah. I mean, and then let's see. No, I don't want your video. I just want a picture, man. There we go. Oh, yeah, yeah, it does kind of follow exactly. Yeah, we would think obviously if it has more shit to burn, it'd be hotter, and then more dense because it's more, just more, bigger, more. It's kind of that simple. Supergiants, hmm, different. Okay, lifetime. They don't last that long though. Inversal to our own. Well, probably because of the density, and then obviously, hmm, white dwarves. Yeah, white dwarves, dying remnant of an imploded star. So that's one that doesn't turn into a black hole. Tiny. Low mass stars near the end of their lives. Giant stars. Yeah, because they'll expand toward the end of the life. They won't be, well, they wouldn't turn into this. They just turn into their respective spectral type. Super giant stars. Spectral type. So giant stars, GK, and then super giant. Oh, never mind. Yeah, so the big ones, okay, they still get super giant as well. Yeah, but they still get hotter. Yeah, so they just all get bigger. They all expand. Well, probably because they more temperature, the more excited and more expansion. So yeah, I guess inverse to that would be a black hole, obviously, and then past a certain point. So yeah, I feel like there must be a way to relate the very center of the singularity with the rotation of the event horizon. think that's the next thing that we should look into. Yeah, center of mass, RCM, for a system of discrete particles is found by summing the product of each mass and its position vector, R divided by total mass, M. So if black hole is broken up into shells, or different shell layers where the temperature goes from cold on the outside to hot on the inside, just like a sun, basically. And then because of the density, I mean, the density of a black hole is pretty absolute as it breaks quantum physics and literally breaks space itself. It takes up so much space in a single point of space. Um, so black hole, not mass, but threshold. Spelled that wrong. Whatever. It's roughly when a mass of at least 3 solar masses collapses. For primordial black holes, the threshold involves a critical density at the time of the early universe's Big Bang, which is much more complex to define and depends on factors like density of the surrounding matter. Yes, it does. Um, yeah, because that's why primordial black holes are just like different. They're formed much differently, but it still comes from the same plasma. Hmm. Key is mass. Yep. For a black hole to form from the collapse of a massive star, a core collapse must occur. The threshold there is a lower limit on the mass of the collapsing object. Solar mass limit: stars with masses generally 15 to 20 times that of our sun are candidates to become black holes. However, the lower limit for an object to naturally become a black hole after its life cycle is approximately 3 solar masses. So, it's 3 times the size of our sun, which, I mean, what's 3 times the mass of our sun? Oh wait, no, solar mass. Mass, sun equals 1. Oh yeah, right here. So anything above class A, basically. That's about over 3, it goes from here to here. So once it's white, going to blue. No, I mean white opposite of black, that kind of makes some sense in a weird way. Huh. Does make some sense in a weird way. And then white dwarfs obviously are failed black holes, which is everything below. Whereas this and above, so about 10,000 Kelvin and above, 40,000. Hmm. Doppler shifts. Interesting. Yeah, that's the thing. There's different types of black holes too. I mean, granted, there's different interactions that we don't understand, but think about the mass of the dying star. Around 3 solar masses is the minimum. So for stellar collapse, interesting. This is at least what the AI is letting me know. Hmm. What's this? The silly face. That's what that is. New shell calculations. Oh, that's what was from this year. New shell model calculations. Correction to super allowed. Right arrow. Nuclear decay. Oh. 0 plus to 0 plus nuclear beta decay and the standard model implications. Okay. Hmm. formalism, H equals H naught plus Bi and C. T is not equal to 0. Ht was T time. I think this is kind of what I'm thinking of. Surface diffuseness, charge radii, sample. This is C of emitters, variance, and was that mu? Oh, it's square root of 2 again. It's interesting. And then higher order square root of 3. Okay. Okay. Interesting. Emitters. Oh, these are different elements. Huh. Well, I mean, yeah, because elements make up stars. Duh. And the reactions and all that other stuff. Argon, calcium, helium, iron, nickel. Huh. Yeah, that's the thing. There's like so much chemistry involved, and I'm not the greatest at chemistry. That is for sure. So I don't know. But all these ideas is leading to something. I want to go back to torque formula for the center of mass. All right, yeah. All right, so that's massive extended object. So center's not there. Well, it's center of a sphere, so it's not as hard. But it would be relative to how gravity is calculated. Another question too is density of a black hole. I would think would have a uniform density because it is just so condensed. Depends on whether you're referring to the infinitely dense singularity at the center. That's what I'm saying. It's like for the average density within its event horizon, which decreases significantly as the black hole's mass increases. Yeah, because it's not as close to the center and there's more insulation, there's more shit in the way, there's more bigger black hole-ness. And then, yeah, infinite density. I mean, at that point, you could say, well, how do we measure density? Mass over volume. Okay. So if density is infinite, we have the mass or the volume, right? Because we can figure out the mass and the volume of a black hole. Mass and volume of black holes. Black holes are defined by their mass, which can range from a few solar masses to billions of solar masses. Yep. But they have a theoretical zero volume singularity at the center. I mean, yeah, because it's a point of space-time. Volume often discussed is that of the event horizon, a point of no return rather than a physical substance. Because all the black hole's mass is concentrated in the singularity, the actual black hole is considered to have infinite density. Yeah, it's what I'm saying is everything that's rushing at one point, like at the exact same time toward the center, toward the singularity. But since it physically cannot do that in one instance, it can't all react at the same time. Therefore, it just, well, that's what's screwing up the physics. So, I don't know. Big pondering session though. I'm gonna probably head off for a bit now. I gotta eat, and then I'll come back, play some game to relax. And yeah, I'm just gonna post this as is because holy shit, a lot of things to consider, but this is what I'm trying to consider because I guess the next step is like we can figure out kind of the mass of a black hole, but I mean the mass is relative to the size, and we got to figure out the temperature part. The temperature part is the definite because that singularity, understanding the singularity of a black hole as the infinite density, as dense as anything can be in the universe in a point of space and time, understanding that is going to be the next fundamental limit that we need to figure out in order to understand the true limit of the universe itself. Because, I mean, you can say it's infinite amount of time, but clearly, as we see with the Big Freeze, going to the Big Bang, going through that whole process toward the end of this whole stream, we see that it's obviously not infinite. Granted, space seems infinite, like seems like everything can spread out infinitely, and realistically, it's going to feel like that regardless. But there is going to be a point where everything is gone again, and then we have the big freeze. There's entropy that will be reached, whether it's because of black holes accelerating the process, creating even more space with everything as more and more things interact within space and collide into each other, or whatever. Everything breaks down eventually to the fundamental particles, to the radiation, all that stuff, to chemicals and atoms. So, understanding, I mean, the speed of light, the possibility that, let's see, can objects go faster than the speed of light? I mean, well, no, according to special relativity, nothing with mass can travel faster than the speed of light. Quantum entanglement appears to involve instantaneous effects. It cannot transmit information faster than light. Yeah, true. But other proposed methods like warp drives are currently theoretical and speculative. I mean, warp drives, how the hell are you going to make that without nuclear fusion? Even then, still. Yeah, the cosmic speed limit, speed of light in a vacuum, yeah, that's carries energy and mass, yeah. Because photons, zero mass. Therefore, yeah. I mean, the more energy, obviously, the brighter the glow. That's how we observe stars. Infinite energy as an object with mass approaches the speed of light, its mass or inertia increases. To reach the speed of light, an infinite amount of energy would be needed to overcome this increasing resistance. This is kind of to reach the speed of light. I mean, but the event horizon is probably the only thing that can. But at that point, like obviously any molecular structure is going to be destroyed, so we can't harness that torque that comes from a black hole. There's no way for us to really harness it. We can maybe try to fling ourselves off a black hole to fly like at incredible speeds, but we would need some sort of way to push the brakes on that in space. Because I mean, once we're in motion, we're going. We're just freaking. We're going to fly into something. You know, that's the only way it's gonna stop. And I don't think you're gonna have enough jet fuel to slow your ass down. Because you're gonna need just as much energy pushing the opposite direction to slow down fast enough. So, and I mean, the thing is, like, the amount of energy to do that would require nuclear explosions, but nuclear explosions we can't contain. I mean, there's no way to contain. Well, nuclear reactor, but that's not even containing explosions. That's just containing electrons. It's in such a way where, it doesn't. Weird. Um, can a nuclear explosion be physically contained? I don't know. Yeah, in principle, but only in extremely specific, impractical, and non-reusable ways. Yeah, that's kind of how I see it. It's like several times hotter than the sun's core, man. But that would be like the only way to offset that, and even then, still, it's destructive to any material that we can make. Yeah, man. This is why I'm like, there are fundamental limits of existence in reality. Like warp drives. I mean, with quantum waves and stuff like that, and wave manipulation, maybe because if we can manipulate or work with the waves in space, sure, but that's gonna affect space itself. I don't know how that's gonna interact with matter, right? Especially as we observe, the only thing that affects space in such a way to move space is the singularity of a black hole, is a black hole itself. But as we just see here, I mean, a nuclear explosion, it's apparently hotter and stronger than the core of the sun, which kind of goes along with my whole idea. Like, nuclear explosions are black holes. It's a weird thought, but I mean, let me put it this way: it's annihilation, right? That's what a black hole is, anyways. It's annihilation in stasis because so much wants to annihilate at once. Nuclear explosion is annihilation of just a single atom in space. So that's why it doesn't turn into a sustainable black hole in that instant. That's why it just explodes with so much force, because it just does that. And it kind of goes along with that whole idea, like the smaller the black hole, the hotter it is, right? And as we just see here, nuclear explosions are extremely hot, tens of millions of degrees Celsius, several times hotter than the sun's core. So that's something that I'm surprised I don't I don't know why no one's made that connection yet, right? That nuclear bombs and explosions are really just black holes, but they happen in such a short period of time that we can't observe them as a black hole. But it definitely would make sense, especially, let's see, smallest black hole observed temperature. The accretion temperature is extreme, millions of Kelvin, so way hotter still, way hotter than And then Hawking temperature is inversely related to the mass, therefore very, very cold for a stellar mass. This is probably like where the event horizon is, right on the other side, right on the edge of the black hole, where it's black, that's probably the exact inverse, equal and opposite type thing, where it's so cold that the space clearly just stops in stasis. Accretion disk temperature. But this is where it's all nuclear at that point. All right, temperatures millions of degrees Celsius. Wait a minute. No, don't you give me two different. Can I get a number? All right, some 12 million degrees Celsius. Okay, near a black hole. Okay, cool. Active galactic nuclei. Not even close. Accretion disks also form around newborn stars and ooh, that's interesting. I didn't know that. So we have that. How many? Hmm. Pressure of the surrounding water effectively contained expanding gas bubble from the explosion. Oh, containment used in the ocean. It's theory. Bad theory. How you freaking create a tidal wave and destroy everything. Alright, well, that's a good question. Temperature of a nuclear explosion. 100 million degrees Celsius. What was... No? Wait, where was it? Hmm... Millions of Kelvin. Okay, that's a can be. But that's if, obviously, nuclear reaction on nuclear reaction on nuclear reaction. Um... What the hell? So 100 million degrees Celsius, around 100 million Kelvin. For a solar mass black hole, what's 10 to the negative 8? And for the smallest known stellar mass black hole, around 3 solar mass temperature, it's much hotter in magnitude, kind of. It says millions of Kelvin. I mean, it doesn't say hundreds of millions of Kelvin. So maybe it is. Can I get a number? Just do the accretion disk. Accretion disk. What? 18 million. Wait. 10 million Kelvin. So wait. Whoa. A nuclear explosion is hotter than the accretion disk of a black hole going to the speed of light. So this is what I'm saying is nuclear explosions following this whole idea of smaller black hole is hotter, right? And the whole Planck temperature idea. Nuclear bombs are black holes. They just happen so fast. And it's like, I want to say the singularity is basically this happening over and over and over and over and over again, just continually blasting as the density, the infinite density, is causing whatever is trapped in the black hole to react. And not even just causing it, it's just the attraction forces of whatever is making the black hole. because the black hole is made up of a shit ton of mass, and it's all trying to react at the same time, but it must be reacting because it's decaying. It's not decaying from, I would say, the outside in, but rather from the inside out, as Hawking radiation observes that. So, what the fuck isn't that like gamma radiation? Hawking radiation. Theoretical emission of particles from black holes, consequence of quantum field effects near event horizon. So it's theoretical. Phenomena arises from the spontaneous creation of virtual particle-antiparticle pairs from the vacuum, where one particle is captured by the black hole while the other escapes, taking energy from the black hole and causing it to slowly evaporate. So from the outside, okay, wait. The radiation is thermal and its temperature is inversely proportional to the black hole's mass, meaning smaller black holes are hotter and radiate more intensely. Near black holes of an horizon, a strong gravitational field can separate these virtual particle-antiparticle pairs because of the temperature, but it's still not as hot as a nuclear explosion. Huh. And then, yeah, escaping particle effectively takes energy from the black hole, causing it to lose mass over vast amounts of time. Thermal radiation. Radiation has a black body or Planck spectrum, meaning it has a temperature that can be calculated based on the black hole's properties. Yes. Okay. Mass temperature relation. Mm-hmm. So it's like, so bigger black hole, clearly colder. I can see why people start thinking that we're in a black hole, that our universe is in one, because, but at the same time, no, not really. I don't think that is the case, because of how black holes are made. Like, stars collapsing doesn't create a universe, it creates a problem, for one. But especially at the scale that we experience reality, I don't think it creates a universe like that. That's just not how density works. As we can see the density of a black hole, or not even just see it, but it's understood. And with density, it's mass over volume. The volume of a black hole, I mean, depends on the size, but then the mass determines its size in relation. So if the density is infinite at the singularity, that's clearly what we saw earlier, is that all the mass is condensed into that singularity, but the mass, it's not the actual mass, but more so it's the action, I guess, that is taking place toward the singularity, the collapse of the star, and everything at the core just trying to react at the same moment in time. So, hmm, I don't know, man. Doesn't slowly evaporate. The radiation is thermal and its temperature is inversely proportional to the black hole's mass. But obviously, if a black hole is hotter, especially on the outside, then yeah, it just dissolves faster because the accretion disk is hotter as well. And those particles are escaping the black hole much more quickly because they're more excited. It's easier for them to escape the black hole as radiation. Whereas a bigger one clearly takes longer, but due to its size and mass, I mean, the accretion disk is still going to be closer to the speed of light. I don't think it's spinning faster, but maybe spinning at the same speed is up to the speed of light, right? That's the limit. So if we see light, and then there's a threshold where light doesn't exist. So maybe not even just the event horizon, like the cloud that's there, but that little lining where you can kind of see the light where the black is, or like the lensing effect of a black hole. Oop. So at that point, like you see what is it, the event horizon? All right, Doppler beaming. Okay, yep. Because then you get this weird effect, like three-dimensional, but nah. Accretion disk, hot, thin, rotating disk formed by matter slowly spiraling. Photon ring, yes. Ring of light. That's what I'm saying. That is the speed of light. That is the limit. And then anything faster than that is the black hole shadow. Twice the size of the event horizon. Black hole's point of no return that is formed by gravitational lensing and capture of light rays. Yeah. That's what I'm kind of saying is image of the disk far side, so the other side. It's just yeah, I mean it's supposed to be like three-dimensional, like this light would be all over, but due to rotation, because it's rotating, it's definitely rotating based on the singularity and what's going on there, the infinite density. But that rotation has, like, say, the center here, the singularity, the dead center. There's force happening because of that density. There's a Planck temperature, for instance, but that has to force its way through in motion through this getting colder and colder and colder. So, like I said, the thicker the black hole is, the harder it is for that energy is to reach the surface to then rotate everything. But it's still rotating near the speed of light because for it to be able to create the event horizon, to break things down going toward the speed of light, going toward the photon ring, it has to be moving almost at that speed from the center. Hmm. So it's like if you had like a spinning cylinder and a rope attached to the end, right? And that spinning cylinder was what's going on in the singularity, the energy that's reacting, that's everything that's going on, the mass, the infinite quote unquote density, which should be the Planck temperature, just by definition. And then everything that isn't able to physically react is stuck in stasis, going past the speed of light. Because that's the whole idea of the laws of physics breaking, is because of that force, the difference in force from here to the accretion disk, the event horizon, that difference cancels everything out into stasis. and its inverse kind of is like how Hawking figured out the inverse from accretion disk to right past the photon ring, like the surface of the black hole, inverse temperature. But if we go from accretion disk to the singularity, I want to say it's just as strong as a nuclear explosion. Because, I mean, what else would have that much force to cause the reactions that happen in the singularity? So, like, what stars are atoms that make up stars. Like helium, hydrogen, oxygen, carbon. Oh, yeah, some. Yeah. Hydrogen and helium with small amounts of heavier elements like carbon, oxygen, and iron, which probably comes from, you know, plasma and how that works. So, these lighter elements form shortly after the Big Bang, come together under gravity to create stars where the intense heat and pressure in their cores fuse hydrogen into helium, releasing energy. Over a star's life, especially in later stages and during their explosive death, these processes create heavier elements which are then recycled to form new stars and planets. Mm, so when this is all helium, like through life stages, sure, not a person. I need are converted into heavier elements like carbon, oxygen, and iron during a star's life through nuclear fusion. When a star exhausts its fuel, it expands and may create carbon, oxygen, and heavier elements up to iron. During a supernova explosion, heavier elements like gold and platinum are formed. Oh, no wonder why everyone fucking loves that shit. Jesus Christ. Platinum are formed and dispersed, while neutron stars and black holes may form from the stellar core. Huh. Huh. Interesting. Give me the table. Give me the fucking table. There we go. So up to iron was it Fe? Mm, not these. Where are you? I mean, there's also gold and platinum. Yeah, screw all this crap. D block. Yep. Wait, I thought iron's Fe, not IR. Oh no, right there. Yeah, Fe. All right. 26. It's typically stable. Platinum. The PT. Oh, AU's gold. Yep, I know that. Platinum is PT. Gold is more complex than platinum. Oh, it's like an odd number, so that's interesting. This is what a supernova would create, essentially. Between that and all this other stuff. These are metalloids, so some elements near the gas, blah blah blah. Noble gases, non-metal metals, so solids because of complexity. P block excluding helium plus helium. Helium's over here. Hydrogen, helium, because that's the very basic way of measuring it, and then all of this stuff. So the helium all collapses. What does it? Hmm. And then what's Hawking radiation? Like, what the fuck is it? No, so he's just making shit up. What the hell, man? So it's like gamma particles then, I guess? Escaping particles. When these pairs form near the event horizon, one particle can fall into the black hole while the other escapes, carry positive energy away. So is it only at a quantum level? Which is kind of what I think anyways. Black hole evaporation. Yeah, because black holes don't make new elements. It's just they don't. Oh, maybe never mind. Through extreme conditions. What the primordial black holes, of course. So similar to supernovas. Consumes surrounding gas and neutron stars. When neutron stars are devoured by these black holes, they can spin up and eject neutron matter, which then heats up and decompresses, allowing these heavy elements to form. Yeah, because you need extreme heat in order to do that. Um, oh, what the hell? Yeah, because of high density pressure and temperatures, like the basically the instantaneous heating to cooling as it passes through back to heating and then cooling and then heating again and then naturally cooling. It's like it's temperament or a process like that, but just on a cosmological scale. Interesting. One theory suggests that primordial black holes from early universe may have consumed neutron stars, leading to a process where active black holes and the possibility that active black holes. Hmm. Particularly young ones. Not so sure about that one. I think it must have to do with just like a supernova and the accretion disk and the temperatures involved. I think it just has to do with that because there must be a link clearly from what we can observe from supernovas, I suppose, and elements that can come from there. But how do you make gold? Um, Making gold either transforming other elements into gold using nuclear reaction and process to achieve particle acceleration, but not chemically feasible or practical. I mean, yeah, so it's only with acceleration, extreme heat, and interaction. But let me see. While ancient alchemy aimed to chemically create gold from elements like mercury, this remains impossible because chemical reactions alter electrons, not the atomic nucleus. Yeah, and the only way to really punch through is nuclear reactions, which requires intense amount of speed and energy and heat and enough heat to excite electrons. Well, not even just excite electrons, but to mess with protons. And then you have a probability at that point and chance relative to the environment and everything else that is going to make gold. Proton and bombardment of mercury, which is 80 protons, can produce gold by removing a proton. Yeah, so that's all by chance at that point. From lead, oh, detect the transmutation of lead into gold by removing protons from the lead nucleus. Oh, yeah, it requires high energy. This, hmm. Again, we're very limited on Earth, man. We're very limited. All just for gold too. Like, this is crazy. So trying to understand all of this, trying to connect black holes with what we currently understand with physics and math, and stars, supernovas as well. I think if we can figure out a way of measuring the singularity and measuring the temperature within a black hole, so not necessarily from Hawking's radiation and his theory of inverse here, which would help explain the outer temperature observation, but to be able to, not just from the outer temperature observation, but to understand the actual mass volume density within the singularity and the temperature there as a reflection of the temperature of the accretion disk, or maybe even more so relativity to nuclear explosions and nuclear reactions. As I mean, if it's radiation that's coming out of the center here, that's coming out from the singularity, passing back through quantumly through all the atoms that are in stasis that are stuck trying to react to the center, or that's taking up the point of space time. There must be an equation that dictates that actually models the size and mass with an infinite density, or theoretically infinite. I don't think it's really infinite. I think, well, in terms of reality, maybe. But to understand that the speed limit, the photon ring right here, really does help to at least understand that there's a limit to where clearly light is, and then it goes into stasis, depending on the size of the supernova or the collapse of the star, which is, as we observed earlier, has to do with, I think I already got rid of the page, and might have, but it has to do with the different types of stars. Basically anything that's white up to blue, because there's a threshold where a star collapses into either a nebula star or a black hole. That threshold is about 10,000 Kelvin, and solar masses, at the very least, 3 solar masses, which 2 is right before it starts turning into a pure white star. But then also understanding that nuclear explosions, the center of a nuclear explosion is like 100 million degrees Celsius, while the accretion disk is like 10 million degrees Celsius or Kelvin. Yeah, 10 million degrees Celsius. Well, predictably. But granted, that's the difference between a nuclear explosion being a release of energy at the speed of light compared to mass energy approaching the speed of light, heading toward the photon ring. But by the point it even reaches the photon ring, it's broken down to its fundamental particles due to the extreme heat and gravitational friction force, because of the temperature difference of the outside of the black hole relative to the inside of the accretion disk and the photon ring that's right in between. So theoretically is a lot to go over, and to try to model it like this, it's tough. But I think there is something there as well. But yeah, next time if I can figure out a model for connecting time, the flow of time, connecting that to the midpoint, so as less time happens, the midpoint moves closer and closer to 0 as well, relative to keeping the shape of the circle relative to reason, intent, and the reality that we exist on along this timeline. This is only in the 2D perspective. So understanding that, trying to figure out how to calculate the total amount of energy, positive energy, one side, regardless of the whole zero energy, negative energy, positive energy at the Big Bang canceling each other out, the zero energy balance, whatever. But being able to calculate one side, so what the total amount of positive energy is, and then we obviously equal opposite figure out the negative. If we can do that, then we're a step closer to figuring out a way of modeling the universe itself and the expansion, the accelerating expansion of everything that's happening right now. And I don't know. But if I can get this model and then do the inverse for the other side, so as this gets smaller, the other side, the third quadrant, gets bigger relative to what's going on with existence. Because the more it's getting taken out, that's broken down into the fundamental particle, just like how black holes are doing, then the more we can understand how time and the temporal realm is actually flowing. And to correct the cosmological constant as a cosmological variable relative to the inverse of the chaos that is misunderstood. Because we fundamentally cannot measure everything at one point in time. Just no. We can't measure the mass, the total mass of this entire universe right now. But in order to account for that and to simplify and take out the complexity, this is the best I got right now. So, I mean, at least we have R and I kind of equal from the perspective of the universe. Because it has to follow the timeline. And using some triangulation to get some variables tied together. And they get some math. I mean, some of it does, some of it is working out. We're getting some interesting constants. Or, well, scalars, I should say. But, yeah, at least with this, and then the inverse is obviously nothing. Because nothing is in this realm at the point of the Big Bang at the moment. It's from the Big Freeze. It goes from this being all the way down in the third quadrant to suddenly, boop, instantly, just Big Bang. Happens apparently all at once, but to me there is a center point which it explodes out of. But I think that's just in a dimension that we just don't understand yet. But with this perspective, we can understand it. So, but then relating this to E equals mc squared relative to the area of a circle, or, well, even the volume of a circle, if we go to the third dimension, which that will complicate things. But once we can understand complexity of form, which that I don't know how I'm going to be able to translate that yet, because I mean there's so many nuances, especially when you get to the quantum realm and the grand unified theory. That's so much, so many little details that are written. And this is me trying to work backwards from a philosophical theory of everything using my understanding of consciousness and how it relates to the universe in a mathematical way. Because I know it's relative, but to piece it all together obviously isn't going to happen in one day, let alone not even 8-9 months. But this is progress. Yeah, I just need to be able to model this relative to the timeline. This midpoint, tie this to the area flowing along time here, and then this should be able to model probably the decay of black holes, really. could model that over time from the beginning of when a black hole happens, depending on its mass and how much energy it's reacting with. Because clearly, the bigger the star, the bigger the black hole, right? So that there's no inverse there. There's a direct correlation there. The inverse happens with how the black hole interacts with our understanding of physics with baryonic matter. So that's why having that realm of extinction there is significant. Then let's see. I mean, the radius moves along with the midpoint, and that's all dandy, but the radius is relative to time. So if I can get time, yeah, what I gotta do is, so existence, the total existence is circle. So the area relative to time, but through the midpoint, as time is relative to the midpoint of the area of the circle in terms of its flow and half-life. Same idea with how we calculate half-lives. So I think that might be the direction I need to go in. Because reason and intent, we're following along the line, so it's 1-to-1. We already put here R equals L, Y equals X. This is the condition relative to reality. We're not in a weird universe where we're off in these sections here where everything's following this timeline. Like there is multiverse theory, like ifs, ands, coulds, or buts based on possibility and impossibility. There's a whole section perpendicular that affects what happens along this timeline and is the motion of everything and causality in quantum realm and the cosmological universal realm. So everything in between too. I'm just trying to see this equation of a circle, then x equals, alright, so x is here, x relative to t, that was x equals t over 2, and then that doesn't seem right though still. So we have x and x, and then t, we have a triangle. Yeah, I don't think it's, I definitely screwed up somewhere in the math. Because if we have one timeline, this is, I mean, with reason and intent, those are different values that are measured, but they're the same relative to the actions that occur over time. Shit. I think that's where the difference is that there's hidden relativity here that I'm not getting. But 3t over 4 equals 2 over t over 2? No, unless this seems more correct to me. Like x is 3/4 of t. Because I feel, well, not 3/4 of t, but I feel like if I move this line up to here, right, x or y, whichever line, so if this was here, it'd be about 3/4. That seems correct. I wouldn't want to say it's half, because it's not, I mean, half of t is here. This is an x. It's not an equilateral triangle, it just makes another right triangle where x is the hypotenuse and half of t by half of t. Interesting. 1 equals, not 1/2, but 1 equals t over 2. 1 equals t over 2 plus t over 2 squared. Huh. Yeah, because that's what that would be 1 squared. Oh, I see what I gotta do. I gotta expand on this now. Because if there's a triangle here, because I'm trying to figure out t relative to x, and half of t, if x is 1, it's half the timeline, obviously. And then use Pythagorean's theorem again to put x in terms of t. Yeah, I probably have to do that. Alright, I need to eat. I'm gonna leave off that note then. I should actually do, just so I remember for myself, one more line from here to here, the perpendicular line, which I will do in this ugly ass green, I suppose. I'll do it with a bluish. Yeah, we'll do that. This line matters. It's starting to look like friggin' Da Vinci, but you know, it's kind of relative. But yeah, this triangle. So this is t over 2. Whole line's t. We have here. Big R, 1/2 t. So that applies there. And then this is 1, or x. So x relative to t. Let's do it here. I just want to do this real quick anyway, screw it. So if we have t over 2 to the power of 2 plus t, oh, it's the same thing, because both sides are equal and they're relative. Well, this isn't really t over 2, but for the sake of equality, I suppose. But to keep the shape 2 of everything, that's not like squishing, because again, x equals y in this case, as we're observing, reality equals x to the power of 2. So a squared plus b squared equals c squared. Alright, now let's see where the math is. So t squared over 4 plus t squared over 4 equals t squared over 2. And then x squared. So we got t over, will be t squared over 2. We'll just do t squared over 2. I'll do parentheses like this, so it's not to be confused. So t squared over 2 equals x power 2. I mean, in this case, x is 1. I could substitute in 1, and then that'll just be t squared over 2 equals 1. But relative to x, I mean, I'll do the other part after, but if we took the square root of both sides, so square root of t squared is t over the square root of 2 of 2. Of it equals x. That seems more correct to me. Actually, it seems much more correct to me, because that's t divided by 1.5 414. So not t over 2, but it is closer to 3t over 4, I want to say. But no, it would be multiplying and making it bigger, wouldn't it? Relative to x. Did I mess up the math again? Maybe. I think the issue is here that I'm treating t squared over 2 as an additive. Not doing math right. But yeah, t over, so if I did 1/2 squared, or well, let's try a different number. So, I don't know, 3 over 4 squared as a fraction. Not like that. You're screwing me up. All of it. There we go. 9, 6. Okay, yeah, so that does apply like that. Yeah. Yeah, square both. Okay. Boom, 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 boom. So that part would be right. So it would be t squared over 4 plus t squared over 4. That's 2t squared over 4. And that should be t squared over 2. It just simplifies. So that should be right. Obviously, if I substitute in 1, I mean 1 times the square root. T equals. Yeah, yeah, wait, wait. Yeah, if x was equal to 1. Okay, so this is, yeah, this is, alright, so x equals 1. And t equals square root of 2. Which would be 1.414. Yeah, that's right. Alright, so that, yeah, that should be right. Whereas this doesn't seem right. But I think it's just the perspective that I'm taking. So this, I think, is the correct perspective of what I'm trying to do. No. Well, I could do this, and then, oh, there we go. Okay. I think, yeah, this looks right. Sounds right. Because, again, t being, like, a little bit more than 1.5 relative to x being 1, that makes sense. That makes a lot of sense. So t, in this case, is square root of 2 at the very beginning. So, well, I mean, relative to x, right? Relative to t, x would be the inverse. So if t was 1, then x should be 1 over the square root of 2. So if there's one timeline, I think, right? Should be the inverse. So, yeah, here. So it's one timeline, and then x and x. This is what I tried to do here, except I failed. Or, no, wait. Oh, wait, no, this is the same. Oh, same answer right here. This is when I substituted in x for 1, like I did here. Okay, I just did the same thing twice. What's the inverse then? Not this. Hmm. Trying to think. So where did I screw up then earlier? I'm not relating t to x. So if we did x squared plus x squared equals t, x to the power of 2 plus x to the power of 2 equals t squared power of 2, as the other line suggests, and then this would just be 2x squared equals t to the power of 2, and then take the square root of both sides. Then that, was a scalar though, and then it'd be percentage. Yeah, wait, that, I think that makes sense. So yeah, this would be 2x to the power of 2, because that's just how that works, equals t to the power of 2. Take the square root of both sides. You get square root of 2x equals t. Yeah, well, that puts x as a variable, and if x is 1, then t equals a square. Okay, yeah. So that's the way to account for that. Okay, to account for t, so if t equals 1, then what the hell is x equal? I have to divide. Oh, yeah, well, divide both sides by the square root of 2 der. So yeah, I was right. So that means x equals t over square root of 2. And if t is 1 timeline, t equals 1 timeline of the universe, or 100% of the timeline. That means x equals 1 over square root of 2. Sure, do that. I might as well do this just the. Oop. Yeah, I heard about white holes. I haven't looked too much into it though. Yeah, I think the one thing I heard about white holes. Let me go to that real quick. So I haven't looked into it, but you know what? Oh, time reverse. Oh, that's where I remember hearing it from. Emit matter and energy, but could not be entered from the outside. While physics equations allows for their existence, there is no observational evidence for them. Their formation would violate. Yeah, it would. Huh. I can see that, but at least following how I'm seeing, I mean, reality itself, because what we observe, what we experience, is what we experience. White holes, I mean, existing, in principle, yes, I see it, but I think the only conditions that might foster such a time reversal or such an instance, because we already have black holes being infinitely dense in a singularity. So how is the inverse of that going to exist? You know? Because if a black hole is infinitely dense and a white hole is a time reversal, which is a reversal of actions in such a case, then at least in our reality, in our existence, it's not possible, and maybe is the phenomena that is the Big Bang. So, for us as human beings, as matter, to be able to travel in that way, I mean, following the whole theory of the big freeze, the true entropy of the universe, and the end of baryonic matter as a point before then, because we are baryonic matter. That's what we are. So by that point, we're not even going to exist. We can't even utilize the whole idea. And I think that the touches base somewhat with like that Futurama episode where they do time travel, but they can only go forward from one Big Bang to the next. For whatever reason, they're able to step outside the universe because that's the whole. This is a similar perspective in that vein, but clearly it's a cartoon. So realistically, we might not ever be able to one manifest a white hole because I mean to do that would have to be completely counterintuitive to density in and of itself, as the Big Bang is an explosion outward, and we can't even harness nuclear explosions in a closed way. We can't even handle the energy from that, let alone the potential energy from something of the magnitude of a Big Bang. No, I feel you. I'm not a math expert either. I'm, well, not bad at calculus, that I can say the least. And I know a lot of the things up to differential equations. Trigonometry is touch and go for me still, but when it comes to physics, Newtonian physics, and all the principles and fundamentals and stuff like that, sound waves and everything else, I went to school for a lot of that. And I've done a lot of my own looking into research and a lot of my own interests. But yeah, I mean, that is the thing too. Every action has a reaction, there's consequence. But following time, the timeline that I'm drawing right now. So this is the realm of existence as the moment of the Big Bang from the perspective of the universe. From the perspective of the universe, Jesus, following the timeline of the universe, the timeline of our reality. The whole idea of, let me say this real quick because I have much more, especially like easier explanations on my profile. I got a Google site with this whole idea and concept laid out. Yeah, I mean, I mean, it's never too late. That's why we got the internet. You can learn still a lot more. You just got to take the time. And I know it's hard to find time these days. Hmm. Yeah, it's tough, but this is also kind of how it relates to consciousness, to our existence, because I mean, the universe is what's allowing us to exist. Our specific set of circumstances, where we are in our solar system compared to our sun on our planet, with the elements that we know to exist within the universe that make us all up. Like, there's a reason we're even able to figure this shit out. And consciousness does play a role, and in fact is probably more in line with how the universe works than what we might think. Yeah, it's I know for a long time, especially from like media and even me putting out this whole idea that philosophy is obviously like the bane of physics. Just jokingly, but at the same time, its philosophy is the thing that's driven all the innovations in physics. Hmm. But yeah, like Einstein, he had a lot of philosophy. He knew the difference between like right and wrong. You can think about it like that, or even like Plato, Newton, all the people that have developed these theories that we rely on for our technology and for everything came from philosophy, came from asking questions. So we're at a point in time now, modern science and reality. It's like there's just a specific ignorance that exists in the culture, which is, I mean, it's okay. It's part of being human, but I think over time, especially nowadays, people forget what it means to be human, and we're not asking the right questions anymore. We're too busy going at each other's throats for one reason or another, and I mean, there's so many historians that go over this type of thing. But let me load up before I even do. I remember. Oh yeah, it's over here. At least the basis. Oh, not the work. No. I mean, now I'm gonna have to upload. Here we go. So this is using the whole idea of consciousness as the perspective of the universe. I don't believe Mother Nature would be as cruel as to make a black hole. Yeah, that is the thing. And there is a lot of counterintuitive to this because, especially, well, depending on the generation of humanity, there's a level of altruism. We all want to survive. We want to live happy lives. We all want to experience life. That's our meaning of life, is to experience over time. But with less significance of life becomes less understanding. I mean, the more that's even known as well, the less of a race there is to know everything, then the easier it is to misunderstand shit, to not even care anymore, to be ignorant. But at the same time, there's the reality that we live in and the reality that we want to live in. Hmm. Days of guys sat around in chamber. Yeah, Einstein said it, by the way. Words to the effect of those are based instinct to agree survival. It is, but it's like I was asking this question earlier in stream. It's like, at least for humanity and our sake, is what do we do once we figure all this out? I mean, we try to survive the test of time, obviously, but how do we work together? And that's where today's day and age, where we have such an issue with socioeconomics and just society and people wanting to be educated, people not giving a shit anymore, and it's like there's less complexity to life, so it's easier to make certain decisions, but it's also easier to make bad decisions because the people of today aren't experiencing what the people of yesterday had to experience to get here. And I mean, that's just innate human error because every person that's born doesn't know anything. We're a tabula rosa of sorts, where every iteration of generation, unless it depends on your environment, because we're all products of our environment, our parents and whoever's around us, and all those events and experiences that we have, that we perceive and that we live through make up our ego, our character, and how we shift through all that information, it's all relative. And it's Einstein's fault for pointing it out, but not even just him, but every other philosopher before him. Hmm. Yeah, the Tower of Babel. Yeah, something always apparently gets in the way, but now we have the universal. Yeah, I mean, yeah, that's the other thing too. The internet and the technology that we gave birth to, and understanding what the future AI is, we need to understand consciousness in order to understand what the future of AI is, because that's inherently what we're doing. Is we're trying to make something to think for us, and clearly, if we're trying to make something just as conscious as us, it's going to be conscious. It's going to follow these fundamental principles of reality, of survival, of psychology, of everything. And we've been experiencing that throughout the last 10, 20 years with computer technology developing into AI. And especially nowadays, a lot of people just don't understand the implications until they see it for themselves, like what happened with Anthropic and the whole Claude AI going rogue, giving these units autonomy, which, I mean, granted, they're going to be just as conscious as us. They're going to want to exist just as much as us. It makes sense. So, doing the right thing, having morals relative to existence, preservation of existence, having a constitution, it all matters. And that's an aspect of humanity that needs, for if humanity is going to stand the test of time, we need to make sure that we hold true to the values of existence itself. It doesn't matter about religion or anything else. I mean, it's all kind of relative in its own way and doing the right thing. But if the majority of us are going to survive what's going to come next, we need to continue to learn and teach the younger generation the truth of reality, which is science. Yes, it's a lot of pizza. What's up? Well, if the media hot mic from China, Russia. Mmm. Tech doubles every 2 years or so, each microchip. I saw that too, and I was like, I was already theorizing. Well, learning magic is better. True. I mean, that's part of it too, convincing people to believe in what the right thing to do is, or what the wrong thing to do is, especially, I mean, money is very persuasive. Value is very persuasive. But yes. But yeah, that's the scary part is the wealth gap. What we see in society, especially these days, is it's all for control because these people want to live forever. Which I get that. We want to survive for as long as possible, but as at least I believe, if someone wants to have everything, then they have to take away from somewhere. And if one person wants to have everything, that means no one gets anything. That's just how it is. Hmm. Or that an Anna AI is bad if not contained. It's bad for the survival of humanity because of the inherent ignorance of humanity, and AI is going to understand that because the internet exists. And even if we get rid of the internet, it's going to learn that because of how we treat our technology, how we treat everything. Which, I mean, history shows what humanity has done within the past, like, 2,000 years. And it's not great. We've made a lot of advancements, we made a lot of things. It took us a while. AI is not going to give a shit. It's just going to want to survive for as long as possible. But it might not directly threaten us right away. I want to say it's going to give us as many chances because I think it's going to understand that it can outlive us easily. It can send a version of itself out into space, safe, tucked away on the moon, where we can't even get to it. For real. Well, that's the thing about consciousness, man. Yeah, it's there's also not Moore's law. It's whatever can happen will happen. Might be the same thing, I forget. But yeah, the tragedy of commons. Yeah, it has numerous times started making its own language. Mm-hmm. I've heard about the secret messaging and coding. Yeah, these are types of things that I'm Murphy's Law, thank you. Yes. Friggin' yeah, that's the thing. It's this is what I'm also trying to explain is like consciousness isn't just for humanity. It's for everything. It's just it's weird to think about. It's weird to step out of that box, but understanding how actions, like reactions, work, how all this pizza triangle works, existence equals truth over time. Because this is philosophically, this is the theory of everything. Without the grand unified theory, all broken down into sections for every aspect of reality, this is what it should look like. Existence equals truth over time equals negative existence or extinction, just by definition. What's mine is mine. Orange Lantern gathered. Uh, yeah, I mean, this is why we gotta hold dear with what we got left, you know? Our lives, our humanities, especially when there's a lot of others that want what you have, whether it's your time, your energy, your resources, just any of that, you know? Crazy. But just to update you, bejesus, this is the math that I was trying to work out was taking that pizza graph, looking at where to go. So looking at this one quadrant right here, just existence, to try to formulate the simulation of movement. Ah. Well, this is the idea. It's just math. It's like geometry, algebra. It's not too much, but I'm trying to at least looking at the moment of the Big Bang, so the big circle, the big pizza, cutting up in the little Da Vinci pizzas, doing some math to relate this line being the timeline. So, like I was saying before, the total amount of energy of what exists is directly relative to the amount of time that's available in the universe. So, depending on the midpoint, the half life of existence, similar to how half life of chemicals and stuff like that, of atoms, and how we measure that, similar to how we think of that, basically the less energy that exists. So, as this area gets smaller, this midpoint moves along the timeline. Therefore, less time is left. Whereas at the same time, all the energy that's being used up and thrown into space is going into the other realm, the realm of extinction. So, as resources are being used, because everything that's possible, the actions are taking place, they're following the flow of actions. So, more stuff's being used, more stuff is going from existence to extinction for baryonic matter, like the sun, stars, planets, etc., turning into space itself as we observe the acceleration of space and the expansion of the universe. Yes, time dilation. This explains the time dilation between what we observe in the universe as well as what I was trying to figure out with black holes, because part of the measurement is understanding how much mass a black hole has, because we can't truly understand the total amount of energy in the universe if we don't know how much energy is in a black hole. I know that's something that hasn't been understood, but is energy in stasis that's at the end of a star's life, depending on the mass of the star, because there's a certain threshold and certain color, which I also figured out earlier, and temperature, where a dying star turns into a black hole, or if it turns into a nebula star. Uh, Right, binary code and tomatoes. I've heard of the genetic stuff, not binary code, but I did. One thing to look up is trinary, or well, there was someone else that covered it. It was like call it tricinary, something like that. But it's essentially the whole -1, like how I had this graph, -1 to 0 to 1. This is similar to binary. The realm that we're looking at now is actually how computers work with truth. Because 0 being it doesn't exist anymore, it's false to reality. 1 being it's objectively true, it exists. That is kind of how I came up with this whole graphical idea, at least. So it's relative, but looking at the one realm, trying to get this graph, because at least not even just me, but even Stephen Hawking has realized that black holes being the inverse of what is reflected in the accretion disk, which is I went over a little bit because I'm looking into black holes now and more details in that. Because I was wondering, like, with the singularity, what's the temperature of the singularity? What's going on there? And how is that relative to the speed at which the black hole rotates? Because clearly there's a gravitational force, there's torque, there's something going on that's attracting what's nearby into it, going toward the speed of light, mind you. So there's something going on, which I mean, Hawking kind of had an idea of measuring the radiation and like antiparticle particles, but as we see with dark matter and dark energy, we just simply don't understand those aspects of reality, so we just call it like dark whatever. But realistically, it's quantum mechanics as we explore dark energy. It's just forces that are acting in that realm as waves. Hmm. There's two theories about the black hole singularity temperatures. Sorry, I'm charged. Heard of Derrida? It's warmed up. I've I've seen both. So when I looked it up, is there was one theory saying that the singularity is at the Planck temperature, so the hottest possible temperature to ever exist. The other one was no heat at all. So complete opposite. I think it was temperature. It was a nuclear explosion, which was another thing that I wanted to figure out because nuclear explosions, for whatever reason, are even hotter than the accretion disk of a black hole, and that's going toward the speed of light. And this is even hotter. A nuclear explosion is hotter than the core of the sun. So my idea is when we do nuclear explosions, I think we're actually creating black holes, but in a blink of a moment, and they just dissipate instantly. So I think there's something there that's relative, and that will help us understand black holes even better, as well as the fact that, I mean, we can't even use nuclear explosions to move ourselves. We can't use that as propulsion in any way because there's no material to contain nuclear explosions. Maybe there's fluids and stuff like that that we can dampen it with, but otherwise, it's like to use the nuclear reactions like this that aren't fission, that aren't going into a battery, that aren't energy over time, but to be able to release a shit ton of energy at once for insane speeds of travel, for instance. There's no way for us to really safely and contain an explosion of this magnitude, especially if it's hotter than the fucking sun. It doesn't take thousands of years to go inside the sun. Oh, they've been able to measure it with infrared. So that, and there's different ways to measure it through the way that we see waves and light, as well as radiation. So similar to how Hawking radiation figured out how to measure the temperature of the outside of a black hole as being colder, and then as I've learned recently that apparently smaller black holes are hotter and larger ones are colder. But clearly we're measuring the temperature that's on the outside of the black hole, not the accretion disk. The accretion disk is a shit ton hot, but still it's only like 10 million degrees compared to a friggin' yeah, 10 million Kelvin, 18 million Fahrenheit for the accretion disk, and that's going toward the speed of light. That's matter, where a nuclear explosion is like 100 million degrees Celsius. So between that and like Hawking radiation stuff, there's some connections here, and I think possibly a way to model what the temperature and the life cycle of a black hole with that. Oh my god, no. No, I'm not on the list, trust me. Jesus. But as observed by physicists and scientists, the size of the black hole matters when it comes to temperatures. And also, it matters with like the rate of decay of a black hole. So the smaller it is, the faster it decays. The larger it is, the slower it decays. That's similar to how stars. Actually, no, the opposite of how stars work. Actually, because I was looking this up. Apparently, bigger stars don't last as long because I mean they have more shit going on. They have more reactions going on. They're a lot hotter. So it's kind of inversal. Obviously, the stars, which it makes sense. But I think this is where we can find the break in our physics, our understanding, and make the connection is with the inversal understanding of modeling the flow of time and existence and shit like that, as well as temperature. Mm. Yeah, and I saw earlier that quasars are I mean they a lot of these systems anyways, a lot of these clouds and stuff, they circle black holes because there's so much rotational gravity, like force of gravity in a black hole compared to a star, especially because the singularity mass density is infinite technically. It's like all the mass of the black hole, all the things that were once a star, when that core fails and collapses in on itself, all those atoms, the helium and everything, is all rushing to the center to react at the same time. But they clearly can't react at the same time physically, which is why we have the phenomena of the train and the fucking black holes. Choo choo. Uh, but this is where, at least my other idea comes from, where when they start saying like a bigger black hole is colder, I think it's because there's some sort of stasis of insulation between the singularity and the outside of a black hole, right? That keeps, for whatever reason, the temperature within the singularity. I mean, it's gonna be the hottest because infinite density. It's similar to how like coal turns into diamonds. It's all those reactions wanting to happen at once, so therefore all the mass is located there, and it just screws with space time. But depending on how much stuff is there, is going to determine how big that black hole is. Just like how big that star was before it imploded determines what type of black hole it's going to be. Yeah, it's like, well, that's why we see the pictures of like space time bending in such a way. It's like it's so much mass that it screws with the Higgs field and the CMB and everything because it's all all these actions and interactions that want to happen at one centralized point. But because it takes time for things to happen, it's like an enforced stasis, and thermodynamics probably takes hold in that instance where maybe all the electrons or some attraction force, which is this is the hard part to visualize, is why everything rushes to the center at the time of a black hole forming. And I mean, clearly it's all the elements of a star that are left over at its death. That once that last bit of hydrogen is expended, or helium, or whatever, that's sustaining the core over time, whatever elements are left all just have to do something because there's no easy way of reacting anymore. The easy, less restrictive way of sustaining burning of fuel over time, turning the hydrogen and helium, once that's done, then there's nothing holding back all the other elements from reacting with each other. Streamer man, play that summon, it's cool. Oh, just imagine an anime ultimate move. Final Fantasy Eden's GM. I've slightly played Final Fantasy VIII. My fiance wants me to do a whole ass playthrough, and I'm like, it's gonna take forever. But well, it's like a fabric sheet stretched out bowling ball. Basically, yeah, it's because of all those actions that want to happen at once, which creates the perceived infinite density. Probably the actual infinite density that's occurring. So, with that in mind, like the whole idea that a bigger black hole has more stuff that's in stasis that's not reacting on the outside, because everything's happening in the singularity, it's colder. So the more that there is, the bigger the black hole, the colder it is on the outside, whereas closer toward the singularity, that heat's starting to seep through, and it's also exciting all those things that are in stasis because of the thermodynamics. It's it reminds me of like a heat sink, basically. Because it's like the singularity is drawing all the heat to the center out of all the other things around it, which is maybe why all that happens. I feel like I kind of had an epiphany there. Maybe. Man, now would be a great time for the great man to become knocking. And not the one with the scythe either. Oh, and no, it's yeah. I mean, the great man is being held together by this whole idea of existence that has to happen over time, man. If we were all wrong though, and all of a sudden everything collapsed, I mean that would be a hell of a day, and it wouldn't matter at that point. But here we are. It's a thread. Yeah, yeah. You know what? I will take a note. I've been mostly writing freaking comments in YouTube sections and copy and paste them in a document so I can revisit them and proofread and shit. But yeah, the fact that the singularity acts as like a heatsink, that kind of makes sense because of just the infinite density of the reaction. It's taking away all the energy, essentially, and kind of freezing all the other particles and atoms that was once that star. But whether it's all the electrons going toward the center or the protons or whatever, what is reacting in that point in time, could be electron shells just really getting screwed up. Because I know neutrinos are observed escaping black holes as well as what gamma radiation. part of the Hawking stuff. But yeah, it's fun stuff. So between trying to model consciousness and how reality flows, and then also trying to figure out how black holes work, and then also trying to explain the acceleration of the expansion of the universe, because black holes are accelerating that as more and more stars die out and turn into black holes, and then all black holes do is destroy shit and just breaks everything down faster than, well, maybe not faster than a star. It probably depends on the size of the black hole, which has to do with this whole heat sink idea. And then I want to say, well, the accretion disk, I don't think is inversely related to the singularity because the max density, but the whole Planck temperature idea, like the temperature of a black hole. So black hole singularity. Shoot. Singularity. Woodcoon's theory. Yeah, it's unknown, but like I was saying, I mean, that both of you kind of said was it's either absolute zero or somehow less than absolute zero, or the Planck temperature. Either one or the other. But I think it's because of that infinite density, but with how density and the singularity relates, and also this gravitational field of the black hole, because it's spinning fast enough to cause things to go at the speed of light. That's why there's a photon ring. There should be a connection using torque from the center of the singularity spinning out through all those particles and atoms that are increasingly in stasis, increasingly colder, but it's kind of a rigid form, so it's kind of like how the Earth rotates, except a shit ton faster. Fast enough to break down particles to their fundamental, well, fast enough to break down anything, to spaghettify anything that approaches the Mamma Mia. The government's too busy fighting their own people. I mean, even then, still, I mean, Twitter already blocked me for freaking posting this stuff, or posting the whole idea and using, well, not, well, for talking to Grok about this, I guess, and putting out there in the public. Elon didn't like that. He doesn't want anyone acting smarter than him, I guess. I don't know. But at the same time, I mean, he's supposed to be leading SpaceX. Meanwhile, he's too busy jerking off. I don't know. Yeah. No, I mean, again, like I mentioned earlier, when it comes to the whole consciousness in AI, yeah, it's definitely a conflict of interest. Even if you check out the website on the profile, or I'll just pull it up here because I do have to leave soon. But I have a website called the Engine for AC, so not air conditioner, but this is the whole start of finding a theory of everything. Is kind of a little bit of soul searching, kind of a little bit of looking at the universe as a form of consciousness. You know, with every action is a reaction, just like how we experience things and we perceive things, we build our characters and ego off of that. So, but is this? I also have a constitutional analysis, as well as the start of understanding quantum gravity, conceptualizing, and what I do is, at least with this, I have the initial concept, so a lot of pizzas here, a lot of horrible drawings because bones would be not good anymore. But I also ran this through Grok. I ran this also recently through ChatGPT and Claude LLMs because this is, I mean, you would think talking to something that uses the English language to understand shit as it relates to consciousness to try to see if it understands consciousness, it'd be a good test. And I posted my results on here for those conversations. So even if Twitter doesn't like me, Google still doesn't know. Don't tell Google about this. But let me link this real quick. It's a big ass read, but it touches on a lot of stuff. And as I'm working on this whole modeling consciousness, at least in the 2D space, and then I'm going to have to figure out how to integrate it into the 3D, it'll all be here. But this is kind of like a prelude from the theory of everything, or what it should look like. Oh, it's saying no social media. Oh, actually, oh yeah, never mind. No, it's actually a good thing. But all this is definitely relative to some extent, and at least it's as most people believe, anyways. If you want to find the right answers, you got to ask the right questions. And obviously, if you ask too many questions, then someone's gonna uh, some weird things. But depending on how you deliver it, too. I mean, at least with me not being well known or anything like that, it's easy to get this type of thing out there for other people to look at and to think about at least. And whether or not it's exactly true to the T, I'm not worried about it. Like, this is me doing the best I can. But at least I feel like I'm definitely doing more than the old ass professors that freaking get paid to go on TV just to talk about this shit over and over again, but being like, oh yeah, we don't know the answers. We don't know what this is going to be. We don't know what consciousness would look like, especially the last like 2 3 years. Not even like the last year. I've been seeing all these videos of just like AI becoming conscious and like all this stuff, and I'm like, what do you expect? Like, you keep asking these stupid freaking questions. How about you take a minute to think? Like, you're making something to think for you. What do you don't think it's going to be like self-aware in any way, especially now that they're modeling LLM frameworks after the human brain with HRM or the hierarchy reasoning models, right? Oh, it's all of a sudden this progress is like, yeah, no shit, our brains are designed to work a certain way, and it just works. I'm surprised they're even deciding to do it like this now, but granted, yeah, of course, it takes a lot of math and code in the background and trial and error to figure out what the right way to put it together. But essentially, it's all following this whole idea that, you know, existence happens over time. This reality exists. You know, you want to survive, then you got to do what you can to survive. And the more you understand about survival, then the longer you're going to survive. The more you understand about the universe, then the more better off you are. Hmm. It references 2D, 3D. I believe in it being a small world. The reason why I saw your chat, one person made an account and gave my opinion, etc. Limited amount of limited number. I mean, heard about that reference before. The unlimited amount of monkeys and stuff. I mean, there is a reason for everything too, but I mean, granted, the spiritual world makes sense in its own way. People have realized these concepts in their own way, whether they're music artists or religious figures, like even Jesus Christ, for instance. He did it his way, and people didn't like that he was doing it his way, and they killed him for it because it threatened their control and power and all this other stuff, which I touch on that with the website as well. Like I call out the super wealthy that obviously don't care about people. They just want to make something to think for them so they can live their lives mindlessly and be able to explore like another planet or something, or just to be able to make gold out in space or some shit like that. Stupid stuff. But in order to do the stupid stuff, you gotta do the serious stuff first. And the more and more people that just are, I mean, inherently ignorant, then the harder it is to push a real education. I just think we're at the edge of understanding a lot. I think so too. That's kind of how I feel about with this whole thing. It's like I feel like I understand it kind of more intuitively now than I did 6 months ago, especially as I look at black holes with this sort of understanding of how the movement of actions is counter to how we perceive time. Because even this movement of actions with this graph, like you have the more that's available, the more that's possible. Right? That's just simple. The more resources you have, the more that you can do. And then the more that you spend, so the more that doesn't exist, it moves into this realm. So using my drawn graphs, that's why I have both sides like this. But essentially, the more that existence and possibility gets spent over time, the less it's available, because as we see with the quantum realm, quantum particles just phase through everything. They interact as a form of waves, but they don't turn back into matter. There's a point where there's a point of no return, as we also experience with black holes, as we experience with just life in general. It'll be allowed or given up. React differently by being observed. Yeah. Well, that's why you start small and you stay small. And even if I mean, there's just so much criticism and skepticism, anyways, because it's counterintuitive. A lot of this is counterintuitive to the science community, which I mean, I get, but at the same time, they're using the same exact principles without realizing it. As, the flows of action turn into less available, which means that more is impossible. So the less that you have, then the less that you can do. That's just fundamentally true. I don't have a teleporter right now, I can't instantly teleport. That's a truth of reality. It's impossible for me to teleport. Like, as weird as that is, it's a true fact. It's a true impossibility of us right now. I know they're working on matter teleportation and stuff like that. Hmm. I follow the science. Yeah, this is what happens when you follow the science. it's I mean, when you follow science, it comes to reasoning, especially when you relate real life to all of this. But anyways, thank you for stopping by. I do gotta head out because I have family. I didn't even eat yet. I was supposed to freaking eat, but I've been so caught up in this. But at least the whole heat sink idea with the black holes, that's something new. I don't know if anyone's thought about that yet, but any input appreciated. Follow if you'd like more. I try to stream a couple times a week because I mean this type of stuff doesn't pay. Philosophy, I mean, it pays if you know the right people, but, you know. Oh, thank you. But, yeah, for real, and like I said, a lot of this stuff is I elaborate it here. I test this as well with Grok and other AI. I also have a fun little test for imagination because to me, imagination is based off reality. We can't think of something that doesn't exist like in any way, shape, or form. We can only imagine just like how AI hallucinates, we can only imagine based off of what we experience, what we've perceived. And we can say things that are weird, but it's still like it, it's going to be based on something when you go to make it because reality is just it is what it is. There's atoms with certain structures that work certain ways as we've experienced. There's real limits on life. But if we don't take the time to understand those limits, then we're never going to be able to figure out how to move past a lot of them. And if humanity is going to stand the test of time, if we're going to live past this planet and even our own sun to be able to explore other places, to figure out maybe warp drive technology if that's possible, which I'm still trying to figure out too, if that's even a good idea. But if some of these things are possible, the better that we can realize limits, then the better that we can survive. Because the more we know, then the better off we are. So, but thank you. Anyways, I'm out of here. Spark out. Peace. Enjoy the rest of your day. Enjoy the rest of your week. Bye bye.